Yeah. Hello everyone. Am I audible?
Yes, sir.
Yes, sir.
Yeah. Okay. Great. So last time we have discussed till span of a set or spanning set of a vector space, and we also discussed what linearly dependence and independence. So today we'll start from basis. Basically, we'll try to find what a basis is. Okay. So any doubt till this point, you can ask here.
I want to ask one general doubt.
Yeah.
Sir, is rank of a matrix same as dimension of a matrix?
Okay, I will come to that. Basically, uh, those two are different things. I mean, the dimension of a matrix does not make any sense. So, dimension of a vector space makes sense, and a vector space can be a set of matrices. So, in that sense, dimension makes sense. But rank of a matrix is different thing. Okay, so those are
Sir, I
not the
am
same
asking
things.
in reference to lecture 4.3.
Yeah,
Right.
yeah, I know.
In
I mean,
that lecture, it is explained that sir has calculated that the rank is equal to dimension of a matrix. Taking an example of a matrix.
no, 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 no. He has not done that. So yeah, I will tell what that is. That is basically I will discuss into the session. Yeah.
Okay, sir. One small request. What
Hmm.
all would you be discussing today, sir?
Yeah.
What are the topics that you would be discussing today, sir?
So the rest of the week 4.
Oh, okay, sir. Okay.
Yeah. So basically spanning set, maximal spanning set, sorry, minimal spanning set, maximal linear dependence, independence set, basis, and dimension rank. These are the 5 things which we will discuss today. Okay. Anyone else wants to ask any question? No?
Sir, will
Yes,
you
sir. A
also
small doubt.
also take some questions after discussing
Question from
topics?
portal, is it? I mean, from activity or practice, are you saying?
Yeah, yes.
Okay, let's see. I mean,
After this, sir, I am asking.
let's see how far we can
Okay,
discuss
sir.
today.
Sir,
Yeah.
one doubt. Sir,
Hmm.
when we are talking about union of some two spaces, so
Hmm.
it will be same like we take a union of two set, or it will be different,
Union means just set union. That is
set union,
same.
right?
Ah.
Like
But the
addition kind
resultant
of
thing may
thing.
not be a vector space.
Sorry, sir. Can you repeat?
The resultant thing, I mean, after taking union of two vector spaces,
Yeah,
what we get that may not be a vector space.
may not be a vector space. Yeah,
Ah. Can you give an example of that?
that will not be a vector space.
So give example of two vector spaces
Yes, sir.
and taking
So,
union of those two, we don't end up in a vector space.
Okay, so sir, any vector space of R2, like
sir,
What?
actually, this is in
sir,
the activity question, sir. I
I
do
know,
have
I know.
doubt in
This is an
this.
activity question. Yeah, right.
as said, so we can take any space of R2 like x comma y,
Okay.
and any vector space of R3, x
Okay.
comma y comma 0. So if we take,
So what is the union? I mean, these two you cannot
I think we can't
take
combine
in.
these two union, right? Yeah,
No, I mean, I want you to take subspaces of a same vector space,
same
basically.
vector space. Okay.
Yeah.
So sir, any vector space like 1 comma x and
1 comma x, is it a vector space? I mean, what is your addition in that case?
Sir, can you take a vector space x comma 0 and 0 comma y?
Hmm. Right.
Yeah,
So
and
basically, if you take x-axis and y-axis,
yes, sir.
yes, sir.
right?
What
Yeah.
will be the union if you take the union of both the vector space? Then
So yeah, right.
it, is it a subspace of R square.
You tell me. So this is with usual addition and scalar multiplication. Okay.
That's what sir was asking. Yeah.
Addition and scalar multiplication.
Yes.
So this is an open question to everyone. Okay. So we'll discuss from here. Okay. These two are subspaces of R2. Correct.
Yes.
Yes, sir.
These two are subspaces. Is it clear to everyone?
Yeah. Yes, sir.
I hope everyone will participate like the previous 3 days. Okay. Okay. So is it? I mean, these two are subspaces clear to everyone?
Yes, sir.
Okay.
Yes, sir.
Can someone tell me why?
Yes.
Suppose the first one. Why it is a subspace?
Yes, because if we take any vector addition, then it will be in the set of the vector. Suppose 1 comma 0 or 2 comma 0, it will 3 comma 0 is in the set. And if we take any scalar multiplication of that, it will also be in the sub v1, and 0 comma 0 is also present in the v1. That's why it is a
Can I
subspace.
add something? Can I add
So-
something?
Yeah.
Sir, this is the x-axis, right? And x-axis is a subspace of two-dimensional. Yes, this belongs to R. X belongs to R. So this is x-axis, and every vector space is a subspace of itself. Is it right?
Every vector space is a subspace of itself, but here I want you to prove that this is a subspace of R2.
Yes,
So,
sir.
it has a zero vector, sir.
Correct.
It is closed on addition. It is closed on scalar multiplication.
Exactly. Right.
Yes, sir.
So if
That
you
is-
check these three, this will be a subspace of R2. Similarly for y-axis also. Now, what is the union of these two? What is the union of these two?
X comma Y.
Sir, I thought x comma y, sir.
X comma Y.
Is
But
it?
No,
Sir,
sir.
it is
All
R2.
points in
So-
X
Sir,
and
I
Y.
think
R2,
all
R2.
element of x comma 0 and all element of 0
Yeah.
comma y.
Correct.
Yes, R2, sir.
So,
Not R2.
Not R2, not R2.
not x comma y.
Exactly.
Not
So
x
V1
comma y.
union V2 is basically this x-axis and y-axis. All those point on x-axis and all those point on y-axis.
Y-axis.
This
Yes.
is
Sir,
basically
you
V1
asked
union.
about the union, sir.
Yeah, that's
When
what
we do
you
that,
Huh?
yes, sir. When we do the union, we can write any point on this xy plane in form of these two
No,
independent.
is it?
That is different. That is different.
1 comma 1 is 1
Yes,
comma
sir.
1 in V1 in V2?
No, sir. Now I can see that how y1 comma 1 is not in v1
Not in
even.
there.
Yeah,
Because
that's
it
what-
is
Yeah.
neither in V1, it is neither in V2.
Neither in V2. Yeah.
Yes, sir. Yes.
And in union, we take only those elements which is present either in V1 or
Or
V2.
in V2. Correct.
Okay.
So
This
it is
answer
like
correct.
1 comma 0, 2 comma 0, 3 comma
Yeah,
0,
yeah,
and
exactly.
0 comma 1, 0 comma 2. Okay.
Yeah,
Exactly.
whatever present
Basically, all the
on
points on
x-axis or
x-axis and
y-axis.
y-axis.
Yeah, yeah.
Okay. So
Yes,
this
sir.
is the union. Union, you know what is the union.
Yeah.
Correct?
Yeah.
Okay. Now, is it a subspace? So first checking, is 0 there? Yes, 0 is
Yes, sir.
indeed there. Right? Because origin is present in both of that. Right? Now the issue is if I take addition of
Please mute. We are not able to hear.
yeah. Now if I take addition, I mean if I take two elements from V1 union V2, is the sum always be inside V1 union V2?
No, no, sir.
Can you give me an example?
Suppose, sir, if we take 1 comma 0 and
Exactly.
0 comma 1,
Exactly.
and if you add, then we will get
Ah.
1 comma 1, which is not in the union.
Exactly. So
Yes.
1 comma 0 is in the union, that is clear because
Yes,
it is
sir.
on x-axis.
Yeah.
0 comma 1 is also in the union because it is on y-axis. If I add these two,
Yes, sir.
what I am getting? This is usual addition, you remember?
Yes, sir.
So it is 1 comma 1. So it does not belong to V1 union V2.
This means it is not closed on addition, right? And therefore it
Exactly.
is not a
So,
subspace.
Sir,
so
if
this
any
is
one
not
of
a,
the condition fails, then it is not the subspace.
exactly, not a
Yes.
subspace.
Yes.
But clear? So this is one crucial example that union is not a union of two subspaces will not be a subspace. Okay.
So it will be always true, or it depend on the condition?
I mean,
Sir, it will
in
depend
some
on the
cases
condition.
it may be a
Yeah,
subspace.
yeah.
So and basically we can prove that it will be a subspace. The union will be a subspace if one is I mean V2 is subset of V1.
So yeah,
Because in that case union will be V1, right?
yeah,
Or
yeah,
vice versa.
yeah, or vice versa.
Only
Correct.
in those
correct.
cases it is possible, otherwise it is not.
Otherwise, it's not possible. Yeah.
Okay. Yeah. So I am stating a fact, I am not proving that for
Yeah. Yes, we will do that.
okay. Yeah. So this part is okay.
We take
Now,
the intersections.
Sir, so we can say that the union of vector subspace spans over x and y axis respectively, excluding all the other point of xy plane that do not lie on the axis in this case.
Right.
Yeah. Thank you, sir.
And what about intersection? Someone asked already,
Yes, sir.
I think. Yeah. So V1 and V2 both are subspaces.
Yes, sir. And intersections, sir, I think only 0, 0 will be there.
In this example, it will be only 0, 0, so it will be a subspace.
Yeah.
But in general,
Yes.
what happens?
General,
Sir, in general,
Can
it
you
will
say
be.
anything?
It will be.
Why? Why?
Only
Because
part.
it will lie on the both. Then only it is intersection. No.
But what is the proof?
yes.
The
Unless
proof
a
will be
subset of
again.
other, then.
The proof will be again all
No,
those
they are
3 points.
one should not be a subspace of other. It's whole generality.
Whole general thing.
Otherwise,
Yeah.
intersection
So
is a
again, we
subspace.
will prove by all these 3 points that yeah, whether
So
zero vector is present or not.
Is in V1,
Yeah.
0 is in V2, as
V2.
both of them are subspaces.
Subspaces.
And it
Correct.
implies that 0 is in the intersection, right?
V1 yeah,
Yes.
correct. That's what I was
For the
saying.
second case, I am taking
Addition,
two V1, V2, two vectors from the intersection. Okay.
and that will lie on the both or not.
So intersection means both of them lie
Common thing, sir.
both of the subspace.
Common thing, yeah.
Okay.
Now, what about the addition? So addition will lie in V1 as V1 itself is a subspace.
Yeah.
V2.
And similarly for V2.
Yeah.
So V1 plus V2 lies in both.
Both.
So the addition lies in the intersection.
Intersection.
Correct?
Correct.
Any doubt in this proof?
No, sir. No, sir.
And similarly,
For the
Scalar
scalar
multiplication.
multiplication. Yes, sir.
So V is in V1 and V is in V2. So CV is in V1 and CV is in V2.
V2.
So CV
And implies we can say that CV in V1 intersection V2.
So
Yeah.
three conditions are satisfied. So it is indeed a subspace. It's a subspace.
So in this case, we can say confidently, right, sir?
Huh?
In this case, like in an intersection case, we can say confidently that it will be subspace.
Because this is the proof.
Yeah, this is the
Intersection will always be a
correct.
subspace.
Correct. Yes, sir.
Okay. This portion is clear to everyone?
Yeah. Yes, sir.
Yeah. So I think it will solve some of your activity questions. or
Yes, sir.
assignment
Yes, sir.
also.
Yes, sir.
It has cleared. the
And lot of
doubts.
conceptual thing as well.
Sir,
Yeah.
intersection, can you explain one more time, please?
So intersection means what we have to check? First of all, 0 is there or not, right?
Yes.
So 0 vector is in V1 because V1 itself is a subspace.
Okay.
Similarly, 0 is in V2 because V2 itself is a subspace.
Okay.
So 0 lies in both V1 and V2. That's why it lies in intersection. Correct?
Okay. Okay. Yes, sir.
So first property holds.
Okay.
For the second property, I am taking two vector from the
Hmm.
set V1 intersection V2.
Hmm.
Okay.
Hmm.
I have to check whether their sum is in the intersection or not.
Okay.
So
Okay.
V1 as V1 is in both and V2 is in both. So V1 comma V2 is in V1 and V1 comma V2 is in capital V2.
Here we are just taking only the 0 part. So V1 and V2 as 0.
No, why 0? These are any two vectors.
Any two vectors.
Any two
Okay.
vectors. So what we have to check for subspace? We have to take any two vector and check that whether sum is in the
Addition.
subspace or not.
Okay.
Okay. So V1
Okay.
and V2 is in V1, V1 and V2 is in V2. That part is clear because this is intersection, right?
Okay. Okay.
So as V1 is a subspace, so their sum lies in the same space.
Okay.
V1.
Okay.
Similarly, V2 is also a subspace, so their sum lies in the space V2.
Okay.
Correct?
Okay. Yes. Yes.
And so V1 plus V2 lies in V1, V1 plus V2 lies in
It's in V.
V2. So it lies in the intersection. Correct?
Okay. Okay.
So the second property also hold.
But then it's a scalar one.
Then scalar one, same thing.
Same thing. Okay, fine.
Same thing.
Got it.
Yeah.
Yes, sir. Thank
Okay.
you, sir.
Yeah, great. So I hope this part is clear. So we will go to spanning set now. Okay, so spanning set we have already discussed. Span of some set. What that means, it's clear. Now suppose we are starting with a vector space V. So V is any vector space. Okay. Now the definition of a basis. I am starting with the definition, then I will come through the motivation of why we are basically doing that. The definition of a basis is, it is a set, subset of V, which, so S subset of V such that S spans V and S is linearly independent. So this set must be a spanning set of V, and as well as it must be a linearly independent set. If these two conditions hold, then we call that set is a basis. Now, suppose in R2, let's start with an example. Okay, in R2. So the natural example I was giving earlier, suppose take this set. This is my S. So clearly S is subset of R2, that we know because we are taking these two vectors from R2 itself. Now we have proved that span of S is indeed R2. All of you remember this thing?
Yes, sir.
Yes.
Else you can prove it basically. Any element of R2 can be written as, suppose
Linear
A comma B
combination
can
of
be written as
this.
linear combination.
Yes, sir.
So this implies the span of S is R2. And is S linearly independent?
Yes,
Yes,
sir.
sir. Yes, sir. It's
Yes.
linearly
So
independent.
we can check by determinant if you want.
Yeah.
So I am writing this as column and the determinant is 1, which is non-zero. So it is linearly independent.
Independent.
So S is linearly independent. So this is a basis, right? By the definition. So S is a basis. Now, my second question which comes here, can a vector space have many bases, more than one basis?
Yes, sir.
Can you give me another example of basis of R2?
So 2 comma 0 and 0 comma 2.
So
1 comma 1 and 0 comma 1.
Anything.
1 comma 1
the
and
other
0
example
comma 1.
which we did earlier, that is this one, right?
And sir, what about 2 comma 0 and 0 comma 2?
That will also be a
Yes,
basis.
yes.
Infinite.
Oh.
So in that sense, sir, basis can be infinite.
Yeah. So there will be infinite number of bases. What you are saying, basically it takes scalar multiple of these two.
Yes, sir.
Yeah. So span of S is R2. Again, we have shown this earlier. And S is linearly independent. That is also we have shown earlier.
Sir.
Right? Yeah.
Sir, what if these two vectors are not given? So how will we prove that it spans R2 or not? Suppose
these
some
two
other
vector not.
Suppose 1 comma 0 and 0 comma 1 is not given. Some other vector is given.
Then you have to check whether That's
So
it. Like this one, no? We have to check that whether that will
we will
span
check.
up to or not.
We will check whether it is linearly independent, and we can check
That is
it
one
by.
checking.
Yes, sir. And how for this whether all the vector can be written as a linear combination of this or not? How we will prove that, sir?
Sir,
So
may
you
I
have
answer?
to, I mean, were you present in the earlier sessions, earlier 3 sessions?
Sir,
Previous
I
three
can tell. I
sessions?
can tell.
No,
Sir,
no,
Sir,
one
both
minute.
of these vectors.
I was not in the yesterday session, sir.
So basically,
Then
you have to take uh, anyone wants
yes,
to
sir.
say anything?
These should not lie on the same line. Then it belongs. Both of them span R2.
But it's better to give the proper idea of
Explanation.
what is going
Yes,
on.
sir. Yes, sir.
So take any vector of R2. That will be of this form, right?
Yes, sir.
Now, suppose some of these, I mean, let's say 1, 0 and 1, 1. So can you write this A comma B as a linear combination of this? That is the question, right? Can you
Yes, sir.
find some X and Y?
Yeah.
If you can find, then you are done, right? What this says? This says that any vector of R2 can be written as a linear combination of these two vectors.
Yes, sir.
That means the R2 will be spanned by this set, correct?
Okay, sir.
That is the definition of span.
Yes, sir.
Okay, so you try to find the equations. So this is x plus y, this is y. So x plus y equal to a, y equal to b. So you will end up in a system of linear equation.
Yes,
Okay?
sir. And I will be able to find the coefficient x and y.
Now
That is
solve
fine,
it
sir.
basically. If you can solve it, then it's done. Okay? Clear?
And I will do this for all everything. matlab, For all the vectors, sir. I mean,
All the
suppose I
vectors
am
means?
given all the vectors, sir. My doubt is, sir, if I am given the vector, then how will I come to know that it is a spanning R2? And you have given
That's
the
what I have
answer
said.
that
No, these two
we,
vectors are given.
yes,
My
sir.
question is
We will try
space
to
span
find that
R2?
whether A comma B will be written in the form of linear combination or
Right.
not.
Can you find
But
x, y like
but
this or
every
not?
time will we be able to find it?
No, not necessary. That is one example we have discussed in live session of Thursday, I think. Okay.
Okay, sir. I will watch
Can
it,
you
sir.
go back and check there? I mean, we have already
Yeah.
discussed all this. Okay.
Okay, sir. Okay, sir. Okay.
Okay.
When you go to the yesterday's session, the first part, sir has discussed it beautifully. So you can check from there.
Okay.
So
Okay.
basically go through
Thanks.
all the live session of this week.
Yeah, he proved it, and
Okay.
he have taken a lot of example as well that how to check in the other dimensions as well.
Oh, thank you. Thank you.
So yeah. So basically definition of basis is clear, right? And it is clear that one vector space has infinitely many bases. Okay.
Correct, sir.
Okay. Now another thing is coming in the picture here, which is called dimension of a vector space. Sometimes it is called rank of a vector space. So rank of a vector space means basically dimension of a vector space. That is not rank of a matrix. Okay, those two are completely different thing. So it's always better to use dimension word here, not rank. Okay, although Sir has mentioned that this is called rank of a vector space, but it's better to use the word dimension. Okay.
Yes, sir, so that we could not able to confuse between.
Exactly. That is the
Sir,
only reason.
sir,
There is no
Yeah.
other reason.
regarding a vector space, are they both equal?
That is what I am saying.
Okay. Okay.
Both
If
are
you are
equal.
talking about a
Then
vector space, then rank and dimension means the same thing. But
yeah,
that is not
Okay.
rank of a matrix.
rank of matrix.
Okay,
Okay,
sir.
rank of a matrix is completely different thing.
Totally different thing. Yeah.
Okay, so this is the cardinality of a basis. Now it can be shown that this cardinality will always be same for all the bases, because I have said that V has infinitely many bases, right? Now why it is guaranteed that all the bases have same cardinality? I mean, without proof we cannot confirm that, right? So there is a proof which says that all the bases have same cardinality.
Yes. Okay.
Okay, and I will tell you why in a minute.
Yeah.
But before that, remember that cardinality of a basis is fixed whatever basis you choose, that does not matter. Okay, the
Of a
coordinate will
gi-
always be same. So the
Sir,
dimension of a vector space is well defined.
Sir, of a given vector space, na? Suppose the vector space is of R2
So what is
and
its dimension?
dimension will be 2.
Exactly, because we have already seen DCS is a basis, so it
Yes,
has
sir.
dimension 2, coordinate 2, so dimension 2.
But the dimension
Similarly,
of the
for the second
R3
example also you
will
have
be
seen
different.
it.
But the dimension of the R3 will be different.
Dimension of R3 will be 3.
3.
Yeah. Okay, sir.
Sir, we can simply take it like we will take all in other coordinate 0 and 1 in one of the coordinate.
Yeah. So basically I will come to that basically. So first of all, I am mentioning here dimension of R2, which you have already seen, that is 2. So in case of suppose dimension of R2, we want to find dimension of R3 now, right? So I am saying this type of element, this type of set. Okay, so this is called standard basis. So this is standard basis of R3. What I am doing basically, at each coordinate I am placing 1 and others 0, right? So these are called E1, E2, E3, so on. Okay, this will always be a spanning set of R3, and this will be linearly independent because that's how it is constructed.
Yeah.
Because when I am putting this as a column, it will give me identity matrix.
Yes, sir.
So the determinant will be 1, which is non-zero. And it is span, that means because at each coordinate I have 1, right?
Yeah.
So once I am taking ABC, a general element of R3, I really don't have to check anything. It is nothing but this combination.
We can simply write in the combination of it.
Okay.
Yes, sir.
So what is dimension of R3? And
3.
I have told that once I know the coordinate of a basis, it will be same for any other basis, and that is called the dimension. So dimension of R3 is
3.
3. Now, can you tell me dimension of Rn?
Yeah.
N.
Yes.
Yes, sir.
And can you give me a basis?
Yes, sir.
Hmm.
Ith. Yes. Even.
L e power
Yes,
En. En.
Yeah.
Where
Yes.
each EI is basically
0.
at
Zero.
ith position Z
I
is
EI is
1.
1.
One.
Ith
Yeah.
And
position
all
there
the
is.
others are 0.
So this is ith position.
Yes, sir.
Right? Clear?
Yes, sir.
So this is very easy till now.
Yes, sir.
We know what is dimension, we know what is basis, we know basically everything.
Yeah.
Okay. Now things can become little bit complicated once we look into the subspaces of a vector space. Okay.
Yeah.
So So again, let's start with a question which I have already set up here. Can you see this slide? Can you see?
Yes, sir.
Yes, sir. Yes.
Okay. I will take this feedback later. Let's go to the question directly first, then I will take that. Okay. So, this question more or less we have discussed.
Yes, sir.
Yes, sir.
Just to recall, both V1 and V2 are subspaces of R2. Is it correct?
Yes, sir.
It's correct, right?
Yeah.
What about intersection? Is it a subspace?
Yeah, that's also correct.
Yes, sir.
That's also correct.
0, 0.
What about union? Is it a subspace?
Yes, sir.
No, sir.
No, sir.
We have proved.
No,
It
this
a
is not.
Yeah. Yes, sir.
Okay.
Yes, sir. Because it will give x comma y, that will not be a subspace of R2. Yeah.
So fourth and fifth option also is not correct because
Yeah.
both V1 and V2 are subspaces.
Correct.
Yes, sir.
Correct.
Right?
Yeah. Yeah.
Now, what about the last two options?
Correct, sir.
Yes.
But
Yes, sir.
last
Yes.
one is
Both are
second
correct.
last is correct.
Because it is asking
Both are-
about the different vectors. Vector
Both are
spaces.
correct, sir.
Yeah.
Both are correct. So,
Both are correct.
yeah, great. So I am going back to my copy now. So my taking the first subspace x0 or x is in R. Okay. Now the set is given 1, 0. This set. This
Yes.
is my S. S is subset of V1. That is okay, right?
Yes.
Yes, sir.
This is a singleton set, correct?
Yes,
So
sir.
this is linearly
Linearly independent.
Independent. Yeah.
Yes, sir.
independent. Okay, great. Singleton set and non-zero vector. So this is linearly independent. Is it spanning the whole V1?
No.
Yes, sir.
Yes, sir.
If we can, yes, sir, we can write
Yes, sir.
as
It
a
is spanning
linear
whole
combination. Yes, sir.
How we can write that? So any element
Sir, we
is
can
of the
write
form
it.
this, right?
Yeah.
Yes,
we
sir.
can write x into 1,
1, 0.
Exactly.
Yes, sir.
So
That is
basically
why
all the
it
elements
is a
are basically
basis.
scalar multiple of this single
Yes, sir.
element.
Yes, sir.
Right? So we can generate any element of V1 by 1, 0.
Yes, sir.
Yes.
So S spans V1.
V1. So it is a
So
basis, sir.
S is a basis.
Yeah.
Yes, sir. Sir, it is kind of a standard basis for this vector.
Exactly. For this
Yeah.
subspace, this is a standard basis.
Yes, sir.
Yeah. So what is the dimension of V1?
Sir, 1.
1.
One.
Is it clear?
Yes,
Yeah.
sir.
Okay. Now let's try to go a little bit further. Suppose I am taking another thing, x and y, such that y equal to say any straight line passing through the origin. I am not fixing any. So okay, let's say 5x. Okay.
Yes,
X
sir.
and y belongs to R. So this is a subspace of R2, right?
Yes, sir.
Correct.
Anybody have any doubt in that? That this is the subspace of R2?
No, sir.
Anybody have any doubt in that?
No, sir.
No, right?
Yeah.
This is a straight line passing through origin, correct?
Yes.
Okay, great.
So,
So now
this
if,
is, so, sir, this is not a vector space, but it is a subspace.
I mean, every subspace is a vector space.
Vector space.
Earlier, you in 26th May
No,
session,
I
you-
have never said that.
Sir, have always said that the subspace will always be a part of.
vector
okay,
space. No?
Yeah.
is not a vector space in 0, 0. Okay.
Yeah.
If we can apply all that 8
Pass
properties
through
on
the-
that,
Yeah.
then
Yeah.
it's the vector
The very
space.
first property is
Yeah.
the subspace will be the part of space, vector
Yes.
space.
Yeah.
So I have a bigger set, which is itself a vector space. Now I have a smaller set. The question
Yeah.
is that a space or not? Is that a vector space or not? Once it is a vector space, we call it a subspace of the bigger one.
Yeah.
That's the idea.
Yeah.
Okay, clear?
So we should look into it like a subset, right?
Yeah, it is a subset.
It is a
It's a
subset of.
subset, but the additional condition is 0 inside that, 0
Yeah.
is inside that.
Yeah.
When I am adding 2 elements from there, the resultant will lie
Then
inside
it should
that
lie
one.
inside that one. Yeah.
And
And the
the
scalar
scalar
multiplication
multiplication
also should lie in this.
Yeah, great. So,
That's
so
very
this question,
confusing.
uh,
When we find the vector space, so we cannot apply the first property of vector space 0, 0.
what
Sir,
is the
I'm
first
little
property of vector
confused.
space? 0, 0 means what?
It's in, we write it
Huh?
Origin.
horizon, yes, sir.
No, origin
It's
I
not.
get, but I am not getting what you are asking. Can you little bit clear?
So subspace condition 0 belongs to,
Subscript condition means 0 should belongs to there. Correct?
yes, sir. But here 0 is not belongs, sir.
No, it is there. X and Y.
Yeah, no?
are.
Yeah.
See, if you put X 0, then Y will also.
So, 1 minute, forget it. Y equal to 5x. Do you know what that is?
Yeah, it's a, line of.
It's a straight
Sir,
line.
it
Right?
is the condition
Is
of
it passing
conversion.
through origin?
Yeah.
1 minute. Is it passing through origin?
Yes, yes. C is 0.
Yes, sir. Yes, sir.
No, let
Because
her
0,
answer
0
that.
satisfies this equation y equal to 5x.
Let her answer that, no?
Yeah.
Okay. Once,
Yeah.
again, I am telling when someone is asking their doubt, let
Let them
clear.
complete.
her answer that.
Yeah.
Yeah. Is it passing through origin?
Yes, sir.
So origin is 0, 0, no?
Yes.
So it has
Sir,
0,
clear.
0. Correct?
Answer clear.
Okay. And you can check other two property also. It will lie. Okay. The sum of two element will be again inside this set, and scalar multiple will also be inside this set. And I have already proved this in some of the live session previously. You can check that note. Okay. Okay. Should
Okay,
I
sir.
go ahead?
Yes, sir.
Okay, great. So now my question is, what is its dimension? Right? So this is a subspace. That means this is a vector space again. So what is the dimension of this subspace?
2.
1.
Sir, 1.
Why?
Sir, because again we can write into like
Can you give me a basis of it?
yes, sir.
1
1
comma
comma
1
1
1
comma
comma
5.
1 1 comma 1
No,
1
sir,
comma
1
5
comma
1
5.
comma
One
5
will not lie in this set.
sorry
Yes,
sir
sir.
1 comma 5
5.
1 comma 5 sir.
Exactly.
Yes sir.
So what we are doing basically, there is one variable
Yes,
which we
sir.
can take as free.
So we
Another is
can
dependent
write
on
y
that.
into like x and then we can find the
So
basis.
take any variable which is free, put one there,
Yeah.
Yes.
and write the dependent variable depending on that, right? So here the
Yeah.
other variable is depending on 5 into the previous one.
Yeah.
So that is 5, and there is no other variable clearly.
Yeah. Yeah.
So here I have a doubt.
Sir, 1 comma 5 comma 1 can also be a subspace of this
No,
set.
no. Why?
I mean,
No,
we are
not
inside
5 comma
R2.
1. It will be 1 upon 5 comma 1. 1 upon 5.
1 upon 1 comma 5.
Yeah.
1 upon
No, sir.
No,
1
no,
upon
sorry.
5 comma 1 will be there, no? Because y is
1
5
upon
times.
1 comma 5 means?
If you put 1 comma 5 at the place of x, you will get y is equal to 1. 1 comma 5 comma 1.
1 by 5, right?
Yeah,
This
1.
was
1 by 5, sorry.
1 comma 5.
that is also okay. That we will also can do.
Yes,
Yes,
sir. 1.
yes,
That's
yes.
what I am saying. Take any variable as your free variable, put 1
Yeah.
there.
Yeah. Yeah.
Derive the what is the value of the other variable.
Correct.
Okay.
Yes.
Yes.
Sir, I have a doubt.
Yeah.
May I ask?
Yeah.
See, in this, which is free variable and which is dependent, how to identify?
You take, I mean, for this case, you take any one.
No. Here we are considering x as free variable, means
You
independent
can
variable.
consider y also as free variable. That does not matter. You will
Okay.
get different basis, but you will get a basis.
So in this case, we can take any of the one, but
there is no hard and fast rule that.
I will come to that later.
Okay.
What is basically the rule there?
sir,
I mean,
free variable
not
generally
rule,
means
that a convention. Probably.
yes, sir. Free variable generally means that independent variable, right?
I will come to that.
Yeah.
But that is basically a convention. That is not a
Yeah,
rule.
correct.
The
Yeah.
convention we take, but
Yeah.
if you change convention, nothing will happen. That I can
Nothing
say.
will happen. Yeah.
Okay, you
Yes.
can still find some basis there if you
Some
know
basis.
what is going on.
Yeah.
Okay?
Yeah.
So,
Is it clear?
Yes, sir.
Sir, if we
who is
remove
asking
this
that
condition,
question?
sir, if we remove this condition, then 1 comma 1 will be there, sir.
If we remove this condition, then this is basically R2.
Yeah, yes, sir.
So basically that's the whole space. Yeah.
Yes, sir. Yes.
Sir, here since one like x is dependent on y or y is dependent on the other, that is the reason the dimension is 1 here.
Exactly. So basically that is number of free variable, number of independent variable.
And sir, just to point out that if we remove this condition, then the dimension will be 2, not 1, I think.
Yeah, because then both of the variables are free.
Free, right?
No one is depending on.
Yeah. So then standard basis again will be 1 comma 0 and 0 comma 1.
Right.
Yeah.
Yeah, Lakshmi.
nothing but R2.
So basically dimension is nothing but the number of components of the vector, right? No, sorry.
Here it is
Independent
not
Number of
possible.
independent.
Number of independent
Number of
variable.
independent components. Independent
Okay,
components.
sir. Okay, sir.
Yeah.
Thank you, sir.
Yeah.
Dimension
We will
is
solve many
cardinality
examples,
of
so you
basis.
will get an idea. Okay, we will solve many examples.
Okay, sir. Thank you, sir.
Okay, so at least this part is clear that this will be a basis, right? This will span the whole space.
Correct.
And this is independent because this is just one single thing, right?
Yes.
Yeah. So dimension of V2 is 1. Okay.
Sir, explain
No
the
doubt till this
dimension
point.
of V2 is 1, no? How?
Huh?
Dimension for V2.
Huh?
It can't be 2.
I mean, what is the cardinality of the basis?
It's like 1 comma 5 is like 1. Okay. Okay.
I mean, this is single element, no?
Okay. Okay.
Hey, at this stage, you should not ask this is a single element or not.
Yeah. This is a single element.
We are
Correct.
inside R2, right? So this is a
Yeah.
single element, right?
Okay.
So cardinality of S is 1, correct?
Yes.
Yeah. So dimension of V2 is 1, okay? Clear?
Yes, sir.
Okay. Now the next question which I am giving, you have to solve it, okay? What is dimension of V3? That is my question.
Sir, 2.
When you are giving me a
One, sir.
solution, you have to also give me the explanation.
Sir,
okay?
Z is independent by itself, and Y or X can be dependent. Y or X, either of can be dependent.
Exactly. Can you give me a basis?
Sir, I can give.
Sir,
Can I?
1 and 2. Sorry, no, sir. Sorry. 2,
Sir,
1. 2,
can I
1.
say 1, 2, 0?
1 minute.
Sir, I'll say.
Basis is of
Sir, 2, 1, 1 or anything. 2, 1, 2. Only X and Y are
So
dependent.
that
The
is only
third.
single element you are talking about, right?
Yeah.
What about 001?
So basically the process is,
Should
here suppose I am assuming X is my free variable and Z is free by its nature, right? Because
2,
no
1,
dependency on it.
3.
So one time we will
No,
take
1 minute, 1 minute,
zero.
1 minute. Let me do that.
Okay, sir. Okay, sir.
Okay. So suppose X is my free variable and this is Z is free by nature. So once you are putting 1 in one free variable, put in the other free variable as 0.
0. Yes, sir.
Okay.
And
So
then
that
in
is
the other
1.
one, we can take 1 as a in the free variable.
Let him
Half
Yeah.
0.
Sir,
Sir,
and one
but that independent Z should always be 0.
Yeah, these two elements will be your spanning set.
Yes, sir.
So is that convention to put Z equal to 0?
Yeah, exactly.
No, that will give you a basis basically. Okay, because what is happening? Remember here, what is happening there? You have to write this general form of element in V3 as a linear combination of whatever you are choosing here, right?
Yeah.
So how the element will look like in general? So X, Y is basically X by 2 and Z like this, right? So if you take this element alone, so if you just put X here, you are getting the first two component, right? For third component, you still have to get. Now, if we put 1 here, what you will get? You will get just X by 2, X. So it is always same as this, but this is not the case. Z can be anything, right?
Yes.
So put 0 here, take Z as it is free, make it free.
Okay, sir. I got till this point, but one doubt, sir. One doubt.
Yeah.
This is possible only if we are assuming it to be R3. We have assumed it to be R3, then only we are seeing whether we are getting all the 3 components or not. First of all, we are assuming that it is R3.
XYZ point
this
is
can
already
be
in
anything.
R3.
This can be any vector. This is the general process.
And
I think there is no
The
assumption.
general process.
Sir, the last part, can you please explain again?
So what I am doing? So a general element of this, how it look like? It look like X by 2 as Y equal to X by 2. And this Z is free. Z has no relation with the previous two.
This is clear. Yeah.
Right. So I have to find two vector, the vectors by which I can span this, right? I don't know how many vectors will be there. But we know that there are two free variables, X and Z, right?
Yes.
Now, somehow I have to, using one vector, I can span this first two part because only X is needed there. And for the third one, third coordinate, which is basically the second vector, which we need, second coordinate, which we need to span this one, right? Suppose I am giving you this relation now. So let me give another relation, then it will be more clear. This relation.
Okay.
This is a new vector space.
Okay.
So in this case, what is happening? How the general form look like? X by 2, X. Right? So basically, one variable is there, one free variable is there. So one vector is enough.
Yes, sir.
This.
Okay.
Right? So using this one vector, I can span the whole space.
So, sir, basically the number of elements in a vector is equal to the number of elements that are independent to span it, right?
No, number of element is 3 inside a vector. I mean, number of coordinate. If you
No,
see.
sorry, like the number of vectors to span is equal to the number of independent elements that are present.
Exactly, number of independent variable. Exactly.
Okay.
Sir, one question I want to ask is, you have given this X, Y, and Z three elements. This means that it should this minimum this spanning set should span R3.
No, it should not. I mean, I am asking for a spanning set of V3 or V4.
Sir, in
subspace of
V4,
R3.
dimension is 1, correct, no, sir?
Which one?
In V4. V4.
V4 dimension is 1 and V3 dimension is 2.
Okay. Sir, it is a subspace of R3.
Subspace of R3, correct.
Yeah, yes, sir. Yes, sir.
Yeah.
Sir, so here basically V4, we are trying to find values for X, Y, Z other than 0.
No, 0 is there, no?
0 is there, but because since for the for the second vector you have put 1, no, sir? With the intention to
here
find
only
the value
one
of
free
that.
variables is there, no?
Because X equals Z.
X is the only free variable. X is same as Z.
No, not in this V4, V3, sorry.
Okay.
In the second vector 0, 0, 1, you did not stop with one vector. You took the second vector in the subspace.
Because there are two free variables, no?
Okay. Got it, sir. Got it.
Got it,
so
no?
here you want to find the value of Z. Y you can get it from X, but
No,
you want to find it for Z.
Just using the first vector, I cannot get the whole general form because there is another free variable, right?
Okay, got it. Yes, sir.
That's why I need a second vector to get the this part.
So if you're able to find the values for all the components in a single vector, then only one vector is fine.
Basically,
right?
that is what free variable means. How many free variables are there inside that? That many vectors you will need.
Okay, sir. Okay, got it.
Okay.
This is that two of the X and Y, these two are dependent, and the third one is independent. We have to take that out.
I am not getting
in
your
the
question.
section.
Can you repeat once?
Sir, I mean to say that we have to cover this X, Y, and Z all three. And in equation, we have to see whether which all coordinates are dependent.
Exactly.
Right. X and Y are dependent on each other.
Right.
And once the Z coordinate is, we are not getting Z coordinate from it. And because this is independent, and we have to cover that Z coordinate using the standard.
Right.
So
for getting a basis, the main process is basically while you are putting, suppose I am getting here two independent variable, right? X and Z. So once you put one in a single variable, in a single independent variable, put other 0. Put 0 in the other independent variable. And in the next case, you are putting in place of Z 1 and put 0 in the other single variable, independent variable.
We are putting a 0 independent and putting 1 in the independent.
So if X is equal to Y plus 2, nothing will change. It won't pass through the origin, I think.
X is equal to Y plus 2, it will not passing through origin.
So
that is not a vector space.
Not even a vector space. Okay.
So we don't need to know what dimension is. Dimension doesn't make sense there.
So it always has to be a multiple pass. It always has to be passing through origin.
Yeah, it has to. 0 should be there, no?
For finding the dimension.
No, for being a vector space, 0 should be there.
Okay, got
then
it.
We can find the dimension.
For vector space or
subspace, then why? Dimension doesn't make even any sense.
Okay, sir. Thanks.
Okay, clear?
Yes, sir.
Clear. Okay, so let's see how it is clear. V5. Okay. I am going to R4.
So, sir, in V4 dimension is 3.
V4 dimension is 1.
1.
So only one element, one vector is needed for the spanning set. No?
Only one free variable.
Right. Number of independent variables. How many independent variables are there?
Only one.
One? Huh? So dimension is 1.
Okay.
So for V3, why you are only choosing 0 as a element? Since it is actually independent, we can have any other number also.
So the process is basically, this is one convention, okay? There are many ways to find a basis. This is one convention I am giving you to find easily. Suppose here I am getting two independent variables, right? X and Z, these are independent, right? Because Y is dependent on that. Dependent on X. First put this, you will get one vector. Secondly, put this, you will get the other vector. And that will basically enough for spanning the whole set. And that will be a linear independent set.
Okay.
Clear?
Thank you.
So, sir, whatever we have basically done till now for finding the dimensions from V1 to V4, it will basically 100% depend on the equation first, how the dimension would be, right?
Exactly. The condition.
Yeah, the condition. Yeah.
So I am going to R4 because I want to give you a clear idea. So don't be panic seeing R4. Okay. I want you to find what is the dimension of V5. Okay. So let's observe what I am doing here. Okay. So first x plus y plus z equal to 0 is one condition and y plus w is another condition. Right? Okay. So if I write these two as a system of linear equation, I am getting this, correct? Matrix representation. Only coefficient matrix I am taking because augmented it is basically homogeneous, so I am not writing that.
Sir.
Okay, yeah. Yeah, tell me.
Sir, okay. Your W, you are taking it as 0. Okay.
Sir, just one doubt. So if it is homogeneous, I'm just getting a bit confused. So we don't have to write it, right? I'm not really clear with the logic of this properly. Like
which one?
Regarding homogeneous.
Homogeneous, if you write 0, 0, the augmented matrix, I mean, whatever operation do we do, this side will always be 0. Right?
Yes,
okay, sir. And one more thing, like what is the significance of a homogeneous linear, like homogeneous system? Like any particular significance, or it's just for the purpose of solving?
I mean, significance means what? What is the significance of non-homogeneous?
Exactly. I mean, but then like we just, I mean, focus on homogeneous, right? In Gaussian also, like.
No, we have solved for non-homogeneous also.
Okay, sir. So no any particular significance as such.
I mean, there can be cases where all these constant term may be 0 or may not be 0.
Okay, so that doesn't matter much, right?
I mean, matter much in which sense? For homogeneous, you know only two cases are possible, right? Unique solution or infinite element solution. No solution is not possible for homogeneous.
Yes, sir. I'm aware of that.
For non-homogeneous, you don't know that.
Okay, sir. Yes.
So if you can identify your system as homogeneous, then it is much easier to predict.
Yes.
Right?
Yes, right. Yeah. Okay, sir. Yeah.
Okay. Yeah. So is it, so I will make it row reduce echelon form. So first element is there. So I am basically doing R1 minus R2 to making it 0, 1, minus 1. So this is in row reduced echelon form?
Yes, sir.
Yes, sir.
Okay. So I am transforming this given equation or given condition in something else. What is that? X plus, so this is X, this is Y, Z, W, right? Z minus W equal to 0 and Y plus W equal to 0. Okay.
Yes.
Okay. So what I can do here, X plus Z is W and Y is minus W, right? Correct? This is what I am getting, right?
Yes.
No issues till this point?
No, sir. No, sir.
So now can you tell me how many independent variables are there?
2. 1.
Which are the independent variables?
W is the independent.
Z and
X and Y, sir. X and Y. They are dependent.
Z and W.
Yes, sir.
Z and W. Basically, it's a convention, what I was talking about earlier. So this is your pivot element, first pivot element in the first row. This is your second pivot element, and there is no other pivot element, right?
Yes, sir.
So these two are your dependent variables.
Dependent.
Where you are getting pivot element.
Yeah.
Yes, sir.
Where you don't have any pivot element, that is your independent variable.
Independent variable.
Okay.
Yeah.
So you make X as your dependent variable. So and W and Z is basically your independent variables. Write it like this. So basically you are getting a general form as W minus Z minus W Z W. Right? Only Z and W are free variables.
Yes.
Correct?
Yes, sir.
This portion is clear to everyone? How I am doing that?
Yes.
Now remember
Yes.
what I was telling earlier, that if you don't follow the convention, still you can get some basis, right? You can consider X as your free variable instead of Z. Then also you get something. And that is correct. That will give a correct basis. But it is a convention to take this pivot element as the dependent and those elements which don't have a pivot element as independent. That is a convention. That is not a rule. Okay? It is clear to everyone?
Yes, sir.
Okay. So now what is the basis? So first put W as 1, Z as 0, right? That is the first thing I have to do. W1, Z0. So this is the first element. And then W0, Z1. So minus 1, 0, 1, 0. So two element I am getting, two independent variables, so two element I will get. So obviously we know that from here itself we know dimension is 2.
Yes, sir.
Dimension of V5 is 2. And here I am getting a basis for that. So this will be a basis. Okay, you can check that this will span this whole thing because that's how we have constructed basically. Right? We can take W1 minus 1, 0, 1 plus Z minus 1, 0, 1, 0. So you will get a general form of the V5. This is my V5 now. So W minus W, 0, W minus Z, 0, Z, 0. So if you add these two, W minus Z minus W, Z, W. So this is the general form you are getting. So clearly this span of S is V, right? And as we have constructed this if you can check that this is linearly independent. Okay. So dimension of
I'm not
V5
getting
is
this. Sir, I have got it V5 is equal to W minus Z minus W, Z and W. Not getting up to this, sir. S is equal to 1 minus 1. How you have taken this?
This till this part you have got?
Yes, till this point I am clear.
Okay. Now what you have to do? There are two independent variables, right? W and Z.
Yes, sir.
Correct? So the process is basically put 1 at one independent variable and 0 in the other. So first I am putting W as 1 and Z as 0. I am getting this first vector. If you put 1 in place of W and Z and 0 in place of Z, you will get the first vector. Similarly, put 0 in place of W and 1 in place of Z, you will get the second vector. And these two elements will form a basis. This set will form a basis. Okay?
Okay.
Yeah?
Yes.
You can check it, basically. You can check that these two are basically linearly independent. I mean, this set is linearly independent and this set spans V5 because as we have checked, you put W here, Z here, you will get a general form. So span of S is V. So S is a basis. And And cardinality of basis is 2, which is equal to the number of independent variable, which we have come across earlier also. So by seeing that, you can say, basically you have to find how many independent variables are there in this type of situation. Clear? Now you can find dimension of any vector space I will give. The process is same. Write the equation, find the independent variables, the number of independent variables is the dimension. Right? And how you can find the basis, that also I have told you. Put 1 in first independent variable, 0 in the others, and go on. Okay?
Yes, sir.
Clear? Is it clear to everyone?
Yes,
Yes,
sir.
sir. Yes.
Okay. Great. So this is one huge portion I had to talk today. Now, let's see what other question I have here. Okay, so let's discuss this problem sometime. Then I will again get back. Yeah. So all of you have a pen and paper with you?
Yes, sir.
Yes, sir.
So in R3, I am getting 3 elements, V1, V2, V3 forms a basis of R3. Okay. And it needs 3 elements because R3 has dimension 3, as we already know. So all the bases must have 3 elements. And it has. Now, which of the following is true? So V1, V2, V1 plus V3. These also form a basis. Similarly, all the other options are there. Now you have to check one by one whether it has a basis, it is a basis or not. Okay, you understood this question?
Sir,
That is what you have to check.
no, sir.
I am not telling you to solve this. I am telling you to understand what you have to check. Okay. So one basis is given. The question is whether the rest set which are given, those are also basis or not. Okay. Is it clear? I mean, at least the question is clear. I am not asking you to solve it now.
Yes, sir.
Okay. Okay. So let me go back here. Now I will come to something is called maximal linear independence set and minimal spanning set. Basically, both of them are equivalent to each other. What does that mean? I will tell in a minute. And both of them is basically a definition of basis. So what does this mean? Suppose in R3, okay, I am starting with easy example. This set is linearly independent, right?
Yes, sir.
This is clear to everyone? This is a singleton set of non-zero vector. I am adding one more vector. Is this still linearly independent?
Yes, sir.
Yes,
Answer
sir.
is yes,
Yes, sir.
right?
Yeah.
Can we add one more?
Yes.
Yes, sir, we can.
And add one more. This is still linearly independent.
Yes, sir.
Can we add one more?
No, then it will become dependent.
No.
No, sir.
No. Why?
Because if we will add
Then
one more, it will be a linear
Linearly
combination of all the three.
Yes, sir.
Because this set, as you are seeing, this will span whole R3, right?
Yeah. Yes, sir.
So any vector in R3 now can be written as a linear combination of these three, correct?
Yes.
So if I put any other vector, that can be written as linear combination of these three vectors. So that will not be linearly independent, right?
Yes, sir.
So this set cannot be extended further to a linearly independent set. So this is the maximal one.
Yes.
There is no other set which is a superset of this, which is linearly independent. That is called maximal linearly independent set. Okay. So basis is itself a maximal linear independent set. And vice versa. A maximal linear independent set is a basis. Okay. So in R3, what is the cardinality of maximal linear independent set?
3.
That is the dimension. Correct? If there are more than 3 vectors, then it cannot be linear independent. That I have said you in last 3 sessions.
Yes, sir.
Remember?
Yes.
Yes.
Once you have more vectors than the dimension, that is actual statement. Then it cannot be linearly independent.
Yes.
Yeah, now you get the idea why I was telling that?
Yes.
Okay?
Yes.
Okay. Great. Now, suppose in R2, I am starting with a set. Is this set span R2?
Yes, sir.
Yes.
This set span R2, right?
Yeah.
Because only first 2 element will itself span R2. Whatever the
Yes,
elements
sir.
are there, we can write it. Right? So this span R2, spans R2. If I eliminate the last one, is it still a spanning set?
Yes, sir.
Yes.
So it is still a spanning set. Can we do further?
Yes, sir.
Yes, sir.
We can do eliminate one more, right?
Yeah.
Yes, sir.
So this is still span R2.
Yes, sir.
Can we eliminate one more?
No, sir.
No, sir.
No, sir.
Right?
No.
So this is the minimal one. We cannot go beyond that.
Yeah.
Right? So there is no other set containing this. I mean, which is a subset of this. There is no other set which is a subset of this, which spans R2. Okay? So this is the minimal spanning set. Okay? And again, you can see that this will also form a basis. Right? So in R2, what is the cardinality of minimal spanning set?
2.
2. Right? That is same as the dimension. In R3, what will be that?
3.
3.
Sir.
Exactly. Clear?
Yes, sir.
Okay. Now, why we are doing this? That is suppose in R3, okay, you are given a set V1, V2, V3. Okay. You know this is linearly independent.
Yes, sir.
Now I am asking, is this a basis?
Yes, sir.
Yes,
Yes,
sir.
sir. It's
Yes, because you don't have to check whether it spans or not.
Yeah.
Yes, sir.
Correct?
Yes,
Because this has cardinality 3 and any maximal linear independent set in R3 has cardinality 3.
Yeah.
And any maximal linearly independent set is a basis.
Basis.
So it must span R3. You don't have to check it. Clear? In R3, suppose you are given a set of 3 elements which is linearly independent. Then the set must be a basis. The set must span R3. And that is also a minimal spanning set. Okay? So, maximal linear independent set, if and only if minimal spanning set, if and only if basis. Okay? Clear?
Yes, sir.
Suppose in R4 or in R5, you have given 5 vectors which are linearly independent. I mean, do you have to check whether it is spanning R5 or not?
No. In R5,
right?
we are given 5 vectors.
5 vectors, then it must be. So only linear independence check is enough.
Yeah.
Okay. Now suppose in R2, you are given a set which, and it is said that, suppose in R2, I am giving 2 elements, V1 and V2. Okay. And I am saying, this is a span, this spans R2. Now I am asking whether this set is linearly independent or not. Is this set linearly independent?
Yes.
Yes, sir.
It must be, right?
Must be. Yes.
Because there are 2 elements which span R2, that means it is a basis. Because it is minimal spanning set.
Yes, sir.
And once it is a minimal spanning set, it is a basis, it must be linear independent set. Clear?
Yes.
So once you know one condition, you don't have to check the other one. When it matches the cardinality of the basis. So when it matches the dimension of the vector space. Okay? Clear?
Yes, sir. May I ask a question here?
Yeah.
Just yesterday when we were discussing this, we were talking about span. You just mentioned that span is something which defines the entire vector space. So now you just mentioned that there is something called minimal. So can we have, like span is not necessarily minimal. Is that the conclusion we can make?
Can you repeat once again?
When a span is, a span is supposed to define the entire vector space, correct? So when we are saying span is supposed to define the entire vector space, having additional vectors like what you showed a little earlier, that also defines the vector space.
The same vector space, this one, right?
So span is not necessarily by definition minimal.
No.
Span can be anything as long as it defines the vector space.
Yeah.
Okay. That was my question.
Actually, this idea came from minimizing how far minimum we can go. So if you take all the vectors of R2, you take all the vectors. That is the spanning set, right? Because it has all the vectors.
So that means R2 does not have like maximal independent set like R3. Because we are saying that it is minimal.
I have never said any of this statement.
Both are equal in the case of R2.
No. See, that I am not saying that both are equal. I am saying any vector space, okay? It must have a basis, okay? And infinitely many bases. All the bases are spanning set and all the bases are minimal spanning set as well as maximal linear independent set. Okay. So in R2, if you have a set of two elements which is linearly independent, that means it's a maximal linear independent set because it cannot go further.
Yeah.
Right?
Okay.
So it's a basis. So it spans R2.
Yeah. So we are able to now correlate linear independence, span, and basis. But how does subspace fit into this? How is it correlated?
Vector space.
So this there wouldn't be any correlation.
Why you are seeing subspace as a different thing? Subspace is a vector space. I mean, subspace is like a subset. You have a bigger space. Inside that, you have a little vector space.
So it won't come into the.
You can talk about the linear independence in between those.
So what we can understand is that because subspace would usually be smaller than this basis. I mean, is it or
not basis.
It's. I mean, the number of elements in a subspace are not linked to basis.
No, I mean subspace also have a basis, right?
Subspace has a basis. Okay.
I mean that's the vector space, so it have a basis.
Okay.
Subspace is a vector space. First of all, take that in your head.
Okay.
Subspace itself is a vector space. Okay.
So I took a subspace and then again I checked the linear independence and minimal spanning, maximum linear independence, and I come at a basis for that. Is that how we see?
Yeah, right.
Okay.
I will give you a proper idea.
Sir,
I will take question once I finish this. I will take your question. Okay.
Okay,
Is
sir.
it okay?
Yes, sir. Thank you.
No, someone else was asking something.
Yes, sir.
No, let me explain this thing little, then I will come to that. Okay. What I am saying in R2, okay. R2 has infinitely many bases and all the bases have same cardinality. It has dimension 2. Correct?
Yes, sir.
This part is clear at least. R2 has dimension 2.
Yes, sir.
Yes, sir.
So if it has a set with two elements, which is linearly independent, that is a basis. Correct? We don't have to check for the span.
Right. Yes, sir.
Now R2 have many subspaces, right?
Yes.
As I have mentioned earlier, one is the 0, 0, only the 0 vector. What is its dimension?
1.
Dimension is 0.
0.
Okay. By definition, its dimension is 0.
Okay.
Because there is no linear independence set. Because only 0 vector is there, itself is a linear dependent set. There is no linear independence set. So the basis are dimension 0.
Okay.
Okay. Okay. Then, so this is the trivial one. We don't ignore that one. So the next thing is all lines passing through origin. That I have said, no?
Yes.
That is another type of subspace.
Subspace.
Now, any line which is passing through origin, that will be of the form y equal to mx, right?
Yes.
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 Just now we have did something like this, right?
Yes.
What is the dimension of this type of space?
1.
1.
Because only free variable is x, right?
Yeah.
Y is dependent on x. Correct? So
Yes.
this has dimension 1. Okay. And another is R2 itself, which has dimension 2. Okay.
Yes.
So R2 is the bigger space. I mean the whole space basically. Inside we have many subspaces. All the subspaces, the possible dimensions are 1, which are straight lines, or 0, or it must be whole space. There are no other option.
Okay.
Yeah.
Yes. Yep.
So I think this will clarify what you are basically asking. So this is dimension 2, which is the whole thing R2. This is dimension 1. These are all subspace of dimension 1, and this is dimension 0. Like this. You can think like this.
Okay.
Okay.
So for the, we've seen example of R2 with dimension 2, and if we see R2 with dimension 1, then the basis for
You
that,
cannot see R2 with dimension 1. You can see a subspace of R2 with dimension 1.
subspace of R2 with dimension 1. Yes. Sir. Okay.
Okay. R2 has always dimension 2. There is no other option.
Okay.
Once you are talking about some dimension 1 vector space inside R2, that means that is a subspace of R2.
And what would be the basis of that one, sir?
You tell me what is the basis of this one?
X 0 comma or maybe 1 comma m.
Clear?
Okay, sir. Thank you.
Yeah. It's clear to everyone?
Sir?
Yeah.
Sir, you have given 0, 0, sir, the dimension 0. Is it a independent?
This is dependent set.
Linearly? No, because singleton set, no?
Singleton non-zero, I have mentioned.
Singleton
if
non-zero
it is singleton
is
zero
linearly.
vector, zero vector is always linearly
That's
dependent.
what, yeah, that's what there is a clash, no? So, okay. Okay.
So zero vector is always, I mean, if in a set there is zero vector, it is always linearly dependent. Okay?
Yes, sir.
Okay. Yeah, someone was asking some question there.
Yes, sir. I have a question.
Yeah.
Single set is always a linearly independent set if it is not non-zero.
If it is non-zero.
Perfect. What about the empty set? It is also linearly independent or dependent?
The empty set does not have a vector. So, I mean, what does it mean?
Okay.
Vector space start with dimension 1, R. Okay, or zero vector, 0. That's it. I mean, empty set does not have any structure. I mean, right? You cannot add anything in there. I mean, there are no element there. So what you will add? Okay.
Sir, you mean to say that
okay. Thank you very much.
If the dimension is n, then subspace possibility is 0 to n. Correct?
Exactly. I was going to ask that. Can you tell me now for R3 what are these classifications are? As you have asked, you have to answer it.
Okay. 0.
0.
1.
So here 0 means 0, 0, 0.
Origin. Yeah, origin.
So this has dimension 0. Yeah. Next.
Next is 2. That is 0, comma 1.
First come, it is 0, then come to 1.
1.
What is that?
Okay. 1 is
all lines passing through.
All the lines.
All lines passing through.
In R3 also we can have like this, right? All line passing through origin.
Yes.
This has dimension 1.
1, comma 0, comma 0. 0, comma, yeah.
Can be anything.
Yes, yes.
Then all planes.
All planes passing through.
What is the dimension of a plane?
2.
Dimension 2. Exactly. Then R3.
Yes.
Sir, all lines passing through origin, sir, the dimension 1, that I didn't understand. How?
The line passing through origin is what is the dimension? 1, right? Here
Sir,
also the same thing, no?
sir, but the 0, 0, 0, if we take 0 vector, so that is the dimension is 0 by default. But passing through origin, how can it be 1? Like, I didn't
So
get.
here, how can it be 1? All line passing through origin?
Sir, I am not
Not
getting
2.
the point. That
This also you have not understood?
No, sir, the rest I have, but this point I'm not understanding.
No,
Like,
this point I am talking about. All line passing through origin in R2. That have you understood?
yes, sir. Like,
What can you explain me that?
sir, yeah, in that this particular thing, one y is equal to x, for example, if we take, so that is a straight line. Sorry, y is equal to 2x. So if we take that, then the one is dependent. No, so suppose x is dependent, so y is independent. So that I understood. Is that right? So in that, y, the number
So
of
what is
independent is
going
1.
different to be here? That is the same thing.
Acha, but here we are having 3 variables, no?
There also we have 2 variables, no?
Yes.
So?
Sir, but oh, no, sir, I'm not able to.
So this is your R3, look like, right?
Yeah.
Now, if you have a straight line like this passing through origin.
Correct.
So I am not going to tell what the equation of this straight line in R3, that will become difficult. So suppose you can think of like this. In R3, you have XY plane, right? This is your XY plane. You have this straight line on XY plane itself. Okay, like y equal to 2x, as you have said.
Yes.
So what is the equation of this set? I mean, this subspace. What is the equation of that? X, 2x, and as there is nothing in z, so it is 0.
Correct.
Right? So this is the equation of a straight line. This is the set form of the straight line in 3 dimension. How many independent variables are there now?
Sir,
One.
One.
Only one.
Right?
Only x.
Yes, sir. Fine.
I mean, do you have any doubt till this point?
Sir, why can't Z also be independent?
No, if you take Z here, then that will be a plane.
Okay. Right.
So
yes,
what
sir.
is happening here? Suppose you take x, 2x, z. You want like this, right?
Yeah.
So there are 2 variables. So now this, I am claiming this is not a straight line. This is a plane.
Okay.
Can you tell me why?
Sir, because it becomes a 3D figure, right? 3-dimensional.
The z will vary. So this straight line, if you vary over z, what do you get? A plane like this. No? Can you visualize?
Yes, sir.
This?
Yes, sir. It's clear.
You just vary this y equal to 2x along this, along z. Z is free, right? So let me open GeoGebra. So this is a good time to open that. So if you write only y equal to 2x, okay, in 3D, you will not get a straight line. You will get a plane. Because on xy plane, it is just a straight line, as you can see, the intersection line. This is the straight line. Now your z is free, so you can move along z-axis above and below. So you will get a plane like this. So this is your 2-dimensional figure. Clear?
Yes, sir. It's clear now.
Clear, no?
Yes, sir. Yes.
Now, if I restrict this, I mean, if I consider z equal to 0 or z equal to some, I mean, 0 I have to take, otherwise no, I mean, origin will not be there. So z equal to 0 means this plane, the xy plane, right? It has some point.
Yes, sir. Yes.
Z equal to 0 means the xy plane. So basically the intersection of these 2 planes will be the straight line. That is 1-dimensional subspace.
Correct.
Correct? That is the
Yes,
straight
sir.
line passing through origin in R3. In R3, what is a straight line? In R3, straight line means intersection of two planes.
Correct. Yes, sir.
Right?
Yes, yes, yes,
So
sir.
intersection of two planes means what? You have two equations and
Yeah.
solution of those two equations.
Correct,
Right?
sir. Yes, yes, yes.
So your variable, the independent variable will be one less.
Yes, correct.
Got it?
Yes, sir. Yes, thank you. Yes.
Okay, great. Yeah, so it is clear to everyone till this point?
Yes, sir. Yes.
Hmm? Clear, no?
Yes, sir.
Solve this one now. Now come back to this and solve this one.
Sir, sorry, sir. Last 2 minutes I couldn't follow because there was some disturbance. Means you told something.
No, I was just explaining why in R3 the straight line is one dimensional.
Okay, okay.
That you can understand, right? Okay. Once you are done, you can just put a like sign here so that I can see how many of you are doing actually.
I'm done, sir.
Okay. Yeah, I am. So basically you see all of this has three vectors, right, in the option. So if you just check whether this set is linear independent or not, you are done. Correct?
Yes, sir.
Is this understandable to everyone?
Yes.
Yes. So basically you have to check whether these three vectors are independent or not. And the given vector v1, v2, v3 are independent.
Yes, sir.
Because that is the basis. So using that, can you prove these vectors are independent or not? That is the question. Okay?
Yeah.
So should I go forward?
Should we have to solve it in METI or something like that? Or what?
So I can post the link here. Okay. So if 8 have solved it, 8 of you, 9.
Sir, only we have to click at that hut if we have solved it because I can't select the option, sir.
I will go to the next slides, then you can select the option.
Okay. Okay.
Yeah. Okay, so many of you have already solved it.
Yes.
Others, I think you have already noted down the problem at least, okay? So I am going to the next slide so that you can put your answers there. Let me see. Oh. Okay. Good. So I am going back to the question slide. So V1, V2, V1 plus V3. First one. Is it a basis?
Yes, sir.
So V1, V2, V1 plus V3, right?
Yes, sir. It's basis.
So you have to check whether this is linearly independent or not.
It's linearly independent, sir.
So this is the thing we have to check. And what about ABC? Whether these are zero or not, all of this. So I will break it down. And I will take V1 common. So A plus C, V1, V2, C, V3. 0. Right?
Yeah.
Now what I have to do? Now V1, V2, V3 are linearly independent. That we know.
Yeah.
Right? So this A plus C must be 0, B must be
sir.
0, C must be 0.
Yes, sir.
Now once C is 0, A must be 0 from the first equation. So indeed ABC are 0. So this is linearly independent.
Yes, sir.
Hence a basis. Is it clear? Do you have any doubt in this?
No.
Everybody, for everybody, is it okay?
Yes, sir.
Yeah.
First option is clear, sir.
First option is clear. Okay. For everyone, right? There is no one who have a doubt in this?
Yes, sir.
Can we solve it using standard spanning set? 0, 0, 1, 0, 1, 0, and 1, 0, 0.
No, because these are arbitrary vectors. You don't know that is the standard one or not. Right?
Yes, sir. From the
This
first
V1,
one,
V2, V3 can be anything.
First one.
I have not mentioned that this is the standard basis. If it was given that it is the standard basis, then you can take that. Otherwise, you cannot. Okay? Clear?
Yes, yes.
Sir, only thing is we should not consider V1, V2, V3 as origin.
But you cannot take any particular example because this is for general.
Origin is not linearly independent.
Even origin, if it has an origin, it is not a basis, right?
Basis, yeah.
Don't take any particular example because this is for any general V1, V2, V3.
General, okay.
Yes, sir.
Yeah.
I have a question. Any basis can be reduced in a standard form. So I think you can assume that B1, B1, B2, B3 are in standard form. Result will be the same.
Then you have to prove it.
No, yeah, of course, because you can reduce any basis to the standard form. This is the how?
Yeah, how? I mean, you are claiming something, but how?
Yes. Suppose we are in the R3.
You give me an example in R2. Don't.
Yeah, you can take R2, and then we can use the vectors in the.
So I am giving you a basis.
Yes. Very easily it can be reduced in the standard form 1, 1, 0, and 0, 1.
How we can reduce this to standard form? This is a basis in R2.
Yes. You can put in the means arrange in the row either row vectors and then yes. Then R2 minus 2R1. R2 minus 2R1. R2 remains, R1 remains the same, and yes.
By row operation, you are saying you will take to the 1001.
Yes. Then it becomes minus 1. Second vector, minus 1.
No, you are going to minus 3.
Okay, right, minus 3. Divide it by minus.
So minus some 3. Operation you will get this.
Yes.
Reduce row.
Now it will reduce in the standard form. Similarly, you can reduce any vector is basis in the standard form, and that's all.
But that does not solve this problem. This is V1, this is V2.
This is, of course, this problem means if you assume that B1, B2, and B3 in the standard form.
1 minute, I am showing you that is not the same thing. Suppose this is V1, this is V2, okay? I am taking this set. I am asking you whether this set is a basis or not. Okay? Now, what is this set? What is this set?
1, 2.
Correct? My question is, this set is a basis or not, right? Now, if you reduce this in this form, then what is your now new V1 and V1 plus V2? Right? These two are not the same set. I mean, am I making any sense? Why this actually reducing does not solve this problem?
No, I am talking different thing. I'm saying if B1 and B2 and B3, suppose B1, B2, B3 are the basis of R3. Then B1, B2, B3 can be reduced in the standard form.
That I agree. That I agree.
Same thing can be happen in any dimension.
That I agree. Completely agree. I am not debating that.
And I'm saying that if B1, B2, and B3 are the basis in any form, then you can always assume that B1, B2, B3 are in the standard form.
No, that is not true. That is what I am saying.
Because B1, B2, B3 is always reducible in the standard form.
No, but that does not solve this problem, because here V1 and V1 plus V2 will be different in both the cases.
But I differ with you, sir.
Okay.
So please go ahead, sir.
But that's only I can tell you, but that actually not solving this problem. As I am giving an example, you can see.
Sir.
You can see, no, this example. This example is saying that is not exactly the same vectors we are talking about.
In this example, take B1, you take B1 as 1, 2, and B1, 2, and 3, 3.
This 1, 2, and 3, 3 also can be reduced to 1, 0, and 0, 1.
If these are the basis, if the 1, 2, and 3, 3 are linearly independent, then it can be reduced in the standard form. That's all. Whether it is a basis or not, I don't know.
How this is solving this problem? Can you tell me that?
Both are the linearly independent. We have to check it.
Okay, so I am giving you another example. Okay, V1, V2 is your basis. Any basis, you can reduce it to 1, 0, 0, 1, right?
Right.
Okay, great. V1, say, is it a basis?
No, because it is B1 is the B1 is the scalar multiplication. Your second element is the scalar multiplication of the first element. This is not a basis.
Then how you will show that? How are you showing that?
Because the second element is the scalar multiplication of the first element. So both are linearly dependent.
Then when I am replacing this by this one, how you are claiming by going to this one?
This is linearly independent. If B1, B2 are linear basis, then it is also a basis.
That is what I was proving. That is what I have proved, no?
Yeah.
That is exactly what I have proved.
Okay, sir.
I mean, maybe I am getting something wrong. I mean, what you are saying. But
he is trying to tell a different method, means to get the identity matrix.
But my point is that is not, I mean, that is not solving this problem particularly.
Okay, sir.
I mean, after that, after you go to the standard basis, then what are you doing? Then what is the way to solve that these three are independent? Then you have to tell me that.
Yeah, it should be homogeneous.
It will become very simple one then.
No, in this
but
case,
then you have to get back to this V1, V2 and V1 plus V3, right? From a basis, you can go to the standard one. Now you are doing some operation there using standard one. Now you have to give me back V1, V2 and V1 plus V3. Can you give me that? I mean, that is not easy. You can give me that, but that is basically reverse row echelon form. So I don't think you can directly do that. I mean, if you know that, that's well.
Oh.
But that is not trivial, what you are saying. Are you getting my point? I mean, basically, you are using a larger tool to solve a simpler problem. And the larger proof really needs proof. Do you get my point, what I am saying?
Okay, sir.
Okay, I don't know I have convinced you or not.
I'm not convinced, but I do not want to, I don't want to debate on this topic. Please go ahead, sir.
Okay.
I'm learning a lot of things from you. So that is the important thing.
No, that is not the point. I mean, maybe
Because
I am wrong, but what I am saying, you
long
just
back,
think on that. Okay.
Long back, I done something in the in the field of vector space. So I recall that memory. Maybe I may be wrong, but I think that any basis can be
that
reduced.
I am completely agreeing to that. I am not debating on that. That is really
that's
clear.
all,
But my point is how we are getting back to this one.
And that this solution, this problem can also be very easily solvable in that if you think that this is in standard format b1 b2 b3 and we take that b1 as a 100 b2 as a 010 and b3 001 and put them, we can always prove that all the bases are the independent, linearly independent.
So even he can share the screen if we're done with the problem. So he can share the screen and let us know at the end of the.
He is arriving at the identity matrix and telling that it is linearly independent.
Perfectly, sir.
And he is taking a small sample of 100, 010, and 001.
He is taking a particular example. That is my point. But this is true
He is
for
taking
any
a particular example. Sir, if I can, 1 minute, can I interrupt? Sir, you are going back to the same problem. V1 is, we have mentioned in the example, V1, V2, V3 is independent. So you are writing that V1 as in a geometrical form 100, 010, and 001. And
what's wrong in assuming?
This may be different, no? I mean, this V1 can be this one also, right?
Yeah. This one also. Yeah.
Right?
Yeah. This one.
Okay. My question is basically this one. I mean, I am not saying you are wrong. Just give me this answer, okay? The question was V1, V2, and V1 plus V3. Okay. So, suppose I have this vector. I want to show that these vectors are dependent, right? You are saying that from this vector I can go to this standard one, this 100, 010, 001, right? Here you are doing the same thing. This is now your V1 prime, V2 prime, and V3 prime. So your V1 prime is 100, 010, and if you add the last two, you will get basically V1 plus V3, so 101. Now this is linearly independent, that I agree, that he is saying. Now, how from this I can get back this? That is my question. Because I have to show this one is linearly independent, no?
Correct.
Till your argument, what I am getting, this one is linearly independent. But
question, sir. Why? Okay.
Yes.
My question is how I can get back to here.
Yes.
I can get back to here somehow, but that
so
is
we
not
have to
easy,
think
that
from
you
a
will
broader
see.
perspective, not from a single example.
Excuse me, sir.
Exactly. That is my point.
Sir,
Make it
but by his theory or way, V1, V2, V1 plus V3 can also be reduced in this form 010, 001.
That is after when you are proving that is the basis, but that is the question, that is the basis you have to show.
Sir,
once you know that this is the basis, you can change it to that.
Yes, sir. We know we are given V1, V2, and V3 is basis, but it is not in the standard form. Okay.
Yes.
Yeah.
So we are converting it into the standard form.
Exactly.
Okay. And again, we are going to the options. Options are V1, V2, V1 plus V3.
Now
and
your
again,
V1, V2, V3 has changed. Remember that. That is not the same V1, V2, V3.
V3 has
changed. You mean to say that we cannot change the basis, right? We cannot alter.
No, I am not saying that. I am not saying
Can
that.
we alter the
question?
Can we alter the basis?
See, the demand of the question is that we have to think from a broader perspective and not from a single
This
example.
is not a particular example. That is my
Because the
point.
question demands like not a single particular example, but a broader example.
I mean,
broader
my
category.
simple question is this making a sense? What I have explained here. Then,
Yeah,
if you can
V1,
answer me this
see,
this
here we
question
are.
mark, then I am okay to take your answer.
But that is what I'm confused about. That V1, V2, and V3 you have taken this thing, and all these processes alter the basis. It has converted from this form to this form. Can we convert it to standard form for solving or no?
Any basis can be converted to the standard form. That is okay. That I am agreeing with by doing row operation. Okay?
Is it allowed in improving such type of questions?
No.
Okay, that's what I am asking, sir. If we cannot alter the basis, then we have to stick to the standard. We have
Because
to generalize.
these two are different.
We have
That's my point is.
We have to solve it in generalized form.
Yeah, right.
Okay.
I mean, otherwise, this again, the second conversion needs some proof. And that proof is not simple. So basically, you are using a larger tool to solve a smaller problem.
May I ask a question at this
Sir,
stage?
excuse me, sir.
Yeah.
Sir, if we take three vectors in R3, suppose the two vectors are linearly independent and the third one is the linear combination of the two. Okay, sir. Sir, can we reduce it into a standard form?
If it is, I mean, third one is linear combination of the previous two.
Yeah, yes, sir.
No, then it is not a basis, no?
Okay, sir. It is not a basis, sir.
Sridhar, what sir is saying,
yeah.
Sridhar, what sir is saying, he is saying that you cannot alter the basis.
Yeah,
like with no
this is not a
I
basis.
know that.
You cannot alter. What you are doing is you are converting it to standard form. That means you are altering the basis.
Okay, but we can
No,
convert.
he is not starting with a
V3
basis. He
Sir,
is starting with V1, V2 and V1 plus V2. It is not a basis.
Yes, sir. It is not a
Right?
basis. But what I am
It's not a
asking
basis.
is
Yeah.
can we convert it into a standard form, or will
Standard
it
form
will,
of what? It is not a basis.
yeah, it is not a basis. So we will, if you try
So
to
what is the
convert
standard
it,
form there?
sir, suppose 1000010 and 001 is a standard form. But
this will not be linearly independent, no?
Yeah, that is what I am saying. So we will, if we try doing that, will we get this or not? We will not get this, I think.
How
sir.
you can get this?
Yeah, that is what I am trying to say, sir. Okay, sir, fine.
May I ask a question here?
Yeah.
In this one, it is written as
we have
V1.
deviated a lot from the original question, maybe. Yeah.
Okay. V1, V2, V1 plus V3, right? V1 plus V3 is going to be 2, 1, and 1. So why is it written as 1, 1, 2?
I have written a mistake, writing a mistake.
Or did you actually put it as V1 and V2, V1 plus V2? Because if it is V1 plus V2, yes, that is
2, 1, 1, right? Yeah. It is 2, 1, 1. Sorry. Yeah.
Okay. In that case, these are independent, right?
These are independent anyway.
Yeah.
That I have already shown, no? Earlier.
Yeah, yeah. Okay. Thank you. Thank you.
Yeah.
So I think we can go ahead.
Yeah. Yes, sir.
Yeah. Probably. Yeah. So, how about the second one?
Yes, sir. It forms the basis.
Is it forms the basis? How we can show that?
By the same way, sir, we can show that.
Again, we can take the same way, right?
Yeah.
This is V1 plus V3. V1 plus V3. Yeah. So this is A plus B plus C into V1, B V2, C V3. So again, V1, V3, V3 are V1. These three are independent. So I am getting three equations which are 0. So A is 0.
Sir, can we also think this in this way, sir? Suppose V1, V2, and V3 are linearly independent. So if we add any two of them, we will get a linearly independent vectors. Can we think in this way?
Independency comes I mean, about the whole set we are talking about, not a particular vector.
Yes, sir. V1,
So you have
V2,
to
and
check
V3.
all the three vectors together.
Okay.
Right?
Okay, sir. Okay, sir.
Yeah. So again, similarly for the third and fourth one, you can check, I think, right? The same way.
Yes, sir.
Clear?
So all forms of basis, no? Okay.
Yeah, all
probably.
basis.
Probably all will form a basis.
So, sorry,
Little
from the discussion and how I solved it, if you arrange the given question V1, V2, V3 in a row form V1, V2, and V3, and all the vectors given in a options, if you put them in a matrix form, and then you perform this row operations,
you will get the defined one.
Yeah. The form given in the question.
Okay.
So the only place where it will not form a basis is having a scalar multiplication, right, of any of the variables.
I mean, if
or any other exception is there.
Combination, yeah. I mean, the last one is coming by
linear combination and scalar multiplication.
Yeah. Last one is a basis. Have you checked that? Last one? Is it a
Yes,
basis?
sir. Yeah.
Sure, no? A plus
Yes,
B plus
sir.
C
It's
minus
basis.
B minus. Okay, yeah, right. So all of this is basis. Okay?
Yes, sir.
Okay, great. This is what is the last thing we have to discuss today. I mean, the last major thing. So we talked about matrix, right? So a set of matrix can form a vector space with matrix operation, addition, and scalar multiplication, right? Now suppose we are starting with a symmetric matrix. Symmetric matrix, you know, A equal to A transpose.
Yes, sir.
Okay. So this is V1. What is this dimension? So for the first case, I am doing that. Rest you will do. So 2 cross 2 we are talking about. So V is the set given, which is V1 basically. A matrix, which is coming from M2 cross 2R, such that A equal to AT, that is symmetric matrix. Okay. So symmetric matrix 2 cross 2 matrix mean what? Like this. Correct? Symmetric matrix will look like this.
No, sir.
No?
Yes.
A raised to T is a transpose, right? How symmetric it means A raised to T is a transpose of the matrix.
Yeah.
A equal to
yes,
A transpose. So A, if it is A, what is A transpose? Am I
AB
writing something wrong?
Same, sir. Same.
Same.
So,
Yeah.
So it should be the symmetric matrix. This is the general form of a symmetric matrix in 2 cross 2. Right?
Yes. Sir.
Basically, mirror image along the diagonal.
Yes.
Right? For 3 cross 3, it will be like, suppose B, C, it will be B, it is D, it is suppose E, then here it is C, here it is C, here it is A. So symmetric again diagonal. Okay? Mirror image against diagonal. Correct? So we are interested about 2 cross 2 now. So this is the general form of the matrix. Correct?
Yes.
So can you give me a basis for this? Can you give me a basis for this?
Who, sir? Two.
Basis. You are saying cardinality of the basis, but first give me a basis. So when I was talking about A, B, C, D, okay, general form of matrices, 2 cross 2 matrices. A, B, C, D are real number. This is general form.
But it would be there would be 4 matrices in this, like.
So there will be 4 matrices. We have 4 are free variables, right?
Yes.
So it is 1, 0, 0, 0, 0,
Yes.
1, 0, 0, 0,
Position
0,
of
1,
1
0.
keeps on shifting. This
So
is the basis.
it plus
Standard,
it is 1,
standard
another
basis.
position it is 0. The same thing. Here there are 4 free variables. Once I am putting 1 in one free variable, others are 0. Correct?
Yes, sir.
Similarly, for here, what we have to do? Here, how many free variables are there?
3,
right? So if I take 1, 0, 0, 0, For B, if we put 1, what I get? And for C, if we put 1, I am getting this. So this is my basis. So dimension of V1 is 3. Is it clear?
Yes, sir.
Yes, sir.
Clear? It's clear, no? No
Yes,
issues
sir.
there.
Yes,
Yes, sir.
Now, what about
Clear,
the
sir, clear.
next one? Scalar matrix. Scalar matrix.
Dimension is
So
2.
only one matrix is
one.
needed.
Scalar matrix 2 dimensions, sir.
Scalar matrix means
2 dimensions.
1 0.
How's general form of scalar matrix look like?
It would be
A,
2.
A zeros.
only diagonals.
A
Sir.
zero, yeah.
A0.
And diagonal should be equal.
Equal. Sorry.
Equal.
So
One dimension.
One dimension.
dimension is
One
what?
dimensional.
Yeah.
Right?
Yes, sir.
Okay. One dimension.
One dimensional. This is a basis. Correct?
Yes,
Sir.
sir.
No issues there? Okay. For diagonal matrix?
It's the same.
2
This
dimensions.
case 2.
2 dimensions, sir.
2 dimensions.
Diagonal
Two.
matrix 2 dimensions.
Because in diagonal position, there can be different, right?
Yes, sir. Yes, sir.
So there will be 2 free variables. Correct?
Yes, yes.
Sir.
Okay. For fourth one, upper triangular matrix?
3 dimensions.
3 dimension.
3.
Let me write that. Upper triangular matrix means what? So A,
1
B, C,
C,
this is 0.
Yeah. Yes.
3 dimensions.
3 free
Three.
variable.
Yes, sir.
So this is 3-dimensional vector space, right?
Yes, sir.
This is a basis. Clear?
Same for lower triangular.
Same for lower triangular, just
Lower dimension.
Lower triangle.
3.
so this is also 3. Okay, so you know how to solve this type of problem, right?
Yeah.
And that is basically dimension of a set where each element is a matrix. Okay, that is not the rank of a matrix. Remember, I am saying it again and again. That is not the rank of a matrix.
Sir, is it possible to tell what is the difference between rank and the dimension?
I am coming to that, but at least this part is clear. What is dimension of this type of vector spaces?
Very clear, sir.
Actually,
Clear.
dimension means in the sense maximum dimension, correct? No?
So dimension means dimension.
Free
There is nothing
variables.
called maximum or minimum.
The
Number of free variables.
Number of free variables or number of element in the basis, basically. Okay.
Sir, in the diagonal matrix, there is a 2 dimension.
Because how diagonal matrix will look like? That was V3, I think.
Diagonals are.
Diagonal can be different, no?
Yes, sir.
So 2 free variables. So basis means? Right?
Yes, sir.
For scalar, it was in diagonal, it will be same. So
Same
only one
element.
variable
So,
is enough.
so one.
Clear?
Yes, sir.
Okay, great. Now, what is the rank of a matrix? This is the last topic in this week.
Yeah, actually, professor told the rank of a rank and dimension both can
Rank
be
and
used
dimension
in-
of a vector space is the same thing, but rank of a matrix is different.
The rank of a matrix are non-zero rows.
Can be used interchangeably.
Non-zero rows in
Non-zero rows of the matrix
row
is.
reduced echelon form.
So
Yeah.
rank of a
Yeah.
matrix means for a particular matrix we are talking about, okay?
Okay, sir.
Suppose I am starting with this.
Okay, sir. These are number of non-zero rows.
Okay, like this. So basically what I am doing, I have to do row operations. So
We have to convert it into reduced row echelon form, right, sir?
Yes.
Right.
Yes, yes.
Right.
Then
So
the number of
class-
non-zero rows in the RREF is
0
equal to
to
rank of
1. Sorry.
So basically next one is what?
R3 minus
R3
2
minus
2.
2.
2 R2.
2 R2.
1, 2, minus 1, 0, 1, 2, 0, 0.
0, 0,
Minus
and
four.
minus 2. Minus 4.
Minus 4,
Sorry, sorry.
right?
Minus 4. Yeah, minus 4.
And again, what I have to do? This is
R3 divided by -1.
So 1, 2, -1, 0, 1, 2, 0, 0, 1. So by here itself, we can know that there are no non-zero rows, right?
Non-zero row and the
But it's
rank is
better
3.
to convert to echelon form, right? So more 3 step you have to do, make this 3 0. Okay.
Yes, sir.
So rank of this matrix, so this is A, suppose. So I am saying rank of A, rank of a particular matrix. That is 3. I am not, but here when I was using rank of a vector space, this is collection of, this is a set. And in this case, basically rank means I am talking about the dimension of the vector space as I have done here.
So, sir, in that rank for matrix, you converted it into a identity matrix, right?
If it is of whole rank, I mean 3 cross 3 matrix, if it is rank 3, then it will be identity matrix.
Okay, always.
If it is a rank 3, it will always be an identity matrix.
Yeah, reduced.
Okay.
But if it is, it may have rank 2, it may have rank 1, that can also happen, right?
Yes. You told this because we have the number of rows is 3. So the rank is 3, right?
Yeah.
Non-zero
rows are 3.
Form is 3.
Okay. Number of non-zero rows.
After converting to row echelon form, remember.
Okay.
Yes.
Not from the
After
beginning.
row reduction operation.
I mean, we can have a matrix like this. You can have this. So basically, the second and third I can make 0, right?
Yes.
Not 3 minus 3 are. Okay. So this has rank
1.
Okay. Clear?
Sir, in the above matrix.
Last matrix, is it?
Sir, I remember like all the pivot variables are dependent variables, right? But here
That don't confuse this with that one. Okay.
it's contrast, that is.
There I was talking about dimension of a vector space. Here I am talking about only for a particular matrix. There are no variable involved now.
Sir, for the last one, sir, for the last one, the rank of the matrix is 2 and 3, no, sir? So 2.
How many non-zero rows are there?
Non-zero rows. Okay, 1. Okay.
1. So that is rank of the matrix. Okay. I am not talking about rank of a vector space. Remember, these two are different. Rank of a vector space, what I was doing earlier, that is a set. And I am trying to find the generator of the set, right? The spanning set of the vector space.
Okay.
Coordinate of that is the rank of the vector space, not the rank of the matrix. Okay?
Okay.
Clear?
Yes, sir.
This is clear to everyone?
In case of vector space, rank and dimension are one and the same thing, right?
Yeah.
Okay.
Yeah.
Got it, sir. Yeah.
Sir, could you please upload this copy immediately after this lecture,
I
if
am
possible?
doing that every day immediately. So if
Okay,
you
okay,
check, you
sir.
will get this.
Sir, in
Yes.
the
Sir, actually, now for the vector space, you will be just to avoid confusion, you will always ask question like dimension, or you will also ask like rank sometimes.
No, so we prefer to use dimension for a.
Okay, that is always preferable. Yes, sir. Yes.
Yeah.
But in the exam also, you will try to ask as a dimension only.
I will ask as dimension.
Okay. Thanks.
I have a question here.
Yeah.
What do we use the rank of a matrix for when, it's
So
something which we are finding out?
I
Where does it?
expected this question, and eventually later week we will have a great application of this rank.
Okay.
So first of all, one example, one application you can see directly, right? If rank is full rank, I mean rank is 3 of a 3 cross 3 matrix, then all the row vectors are independent.
Independent, yeah.
Yeah, that is one thing. And more often, I mean, this, if you calculate the determinant will be non-zero.
Yes,
so the
obviously.
the matrix will be invertible.
Yes. Okay.
Right. So using rank, you can predict all those things.
But why do we need to find a rank for determinant? Because for calculating determinant is easy, isn't it?
But not always calculating determinant is easy, because rank, you know, some algorithm, right? Only using class and scalar multiplication, right? If you write a program for that, that will take less time than doing product.
Yeah. Oh, okay. Got it. Finding the determinant.
From a programming perspective, this is easier to find a rank.
Okay.
And to find, and if you write this code, I mean, for doing lower operations, so you can directly solve system of linear equation using that. You can find the rank, everything. Right?
Okay.
And it has a relation with, so the main thing is it has a relation with linear transformation, which will come in the next week.
Okay. Okay.
Linear transformation. There is something called rank and nullity.
Rank and?
So there, rank and nullity, something called nullity is there.
Okay. Okay.
So now these two will be completely related to each other.
Okay. 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 All right. Thank you.
Excuse me, sir.
Sir, for some time, can you put some light on basis?
Can you go back to the live session from the beginning and check that?
Okay, sir.
Because
So
from
did
the
you?
start, I am doing basis.
So I get the definition of dimension and rank is the same thing, but I didn't get. Did you said rank is a set?
No, I never said rank is a set.
Okay, it's a
When
single
I am
value.
talking about a vector space, and if somewhere you see the rank of a vector space, that means dimension of the vector space, right?
Okay. So it's a
And
single
if you
value.
see rank of a matrix, rank of a particular matrix, then you have to calculate the row reduced echelon form and find out the number of non-zero rows there.
So it's the rank / dimension is a single value, no? If someone asks me that what is a
It is always
dimension
single
of
value for both the cases, rank, a dimension,
yes,
and
yes.
for this rank also.
Okay. Thank you.
But no, you are confused in that sense. Rank
No,
and
sir.
dimension of a vector space, that is different. And rank of a matrix is a different thing.
No, sir. I get rank of a matrix is a different thing, and rank and dimension is the same thing for a vector space. But I was confused. Like I thought you said it's a set. So when we did previous questions, there was a single value for the dimension. So
It's not a set. I am saying it is the cardinality of a set, which is the basis, basically cardinality of the basis, right?
Okay.
Here rank means cardinality of this basis. That is the dimension. That is the definition of dimension, right?
No, so if
Cardinality of the
someone
basis.
asks me what is the so cardinality is a single value. Here it is 3. Okay.
So rank of this vector space is 3.
Okay.
Okay.
Yes, got it.
Sir, one attribute more I have read somewhere, which is size. Size of a matrix, rank of a matrix, rank and dimension, you told the same thing. But what is size? Because I read in the reference book size and dimension.
Size means this n cross n, this is the size. Suppose 2 cross 3, that is the size of a matrix. Okay, how many rows?
What are the topics for mock test today? Sir, what are the topics for mock test today?
All the topics of quiz 1, week 1 to 4.
Sir, can you explain again how to find rank A, B, and B3?
Do the row reduced echelon form, find the row reduced echelon form, number of non-zero rows in that.
Sir, the number of non-zero rows, non-zero rows. Okay, sir.
That is the single thing.
Sir,
okay.
For the mock test, it is 1 to 4, is it?
Yeah.
Okay. Week 1 to 4.
Yeah, that is the syllabus for the quiz, no?
Okay, yes.
So, yeah, if this matrix has rank 2, find the value of A. Can you solve this now?
Yeah, already solved. It is 5.
How you are solving this?
First, performing row operations and making one of the row with only the last column and last A portion. The 1 and -3 should be 0.
Exactly. You want to make this last row to be 0, basically, because it has rank 2. So make the previous 2 as non-zero rows. So what should be the value of A for which the last row will become 0 after row operation? Right? That is the value you want to find. Clear?
Sir, what is the answer to it? We can, I
have
can
anyone
solve it later.
calculated? I forgot.
Five.
Fine,
Single
we'll check
number
that.
five.
Okay, we'll check that.
Okay.
Yeah. Okay. So hopefully, I mean, I somehow make all the concepts of week 3 and 4 together in these 4 consecutive live sessions. So
So I
hopefully it
don't
will
know.
be of some use.
So I don't know. I should say this, but actually, you taught better than the Sarang sir.
Sarang sir is my PhD guide. So
I don't know. I don't understand the lecture because I attended
no,
your
in lecture
three.
in a short time he has to explain many things. No, so that is quite
You are
compact.
giving
He
the
has to do.
clarity. Thank you so much, sir.
Yeah. So can you, I mean, fill this form for again who are just attending this session to get that data?
Can you paste the link?
Is it okay if I ask? Hello.
Hello. Excuse me, sir.
Chronic for life.
I think you can use link he sent. It's showing the same.
Sorry, it's gone.
Is this the end of the class?
Yes.
I think so.
Okay. Thank you. Bye.
So the session is over.
I think so. Sir is not there now.
Okay.
Yeah.
So just wanted to ask for the quiz. If we go through the live sessions, will it suffice, or we have to do some additional things?
Don't know this term. The instructors, they didn't give any clue.
They are actually.
Yeah, last time we
I
got
just wanted
everything.
to ask. Last time almost everything was.
Yeah, we got a somehow. Yeah, for 70% of portions they covered in
Actually, I
that.
wanted to ask the instructor whether any sample or anything you will be.
Yeah, what is the proportion of the mark
Last
distribution?
time we had revision and all. This time.
Yeah, we don't have or not.
No, that I wanted to ask, but I think that's why I'm asking whether he has left or means for him some internet.
I don't know. His side some issue happened and he left, or he left like that.
Are
I
you
don't know.
guys also finding difficulty this time? I thought it's only me.
Yeah, it is a little tricky only.
I think till now it is easy, but it will be hard. It will be
Going to be hard next. Okay, but I don't know. I'm some questions. No,
Even in this these 4 weeks also, not all the questions are simple. Na? Some
yeah,
are.
even
I mean,
activity
some are
questions,
little tricky also. I mean,
yeah,
I'm
activity
struggling
questions
a lot.
difficult. Even I
I'm
am struggling.
struggling a lot.
I am finding little difficult only.
I am
Yeah.
writing this.
No, this term is difficult only.
Because
whoever is-
maths too in itself is little bit, I mean,
yeah,
not so simple, no? It's
yeah.
complicated.
Now
And
recently,
they,
whoever is doing.
and they
And
name it as M2 also. That is
Sorry?
they name it as M2 also, like version 2.
No, I would have suggested to little bit give some extra classes because see, this vector space and all means it is not like regular topics. We don't study and all.
I think we need to solve lot of sums. I mean questions.
Questions.
To
Yeah.
get
Even with
There is enough questions in the activity, but getting the answer and after getting what we did is right or wrong, that also we cannot identify from that. No? They are not giving any
I
solution.
just wanted to ask what will be the percentage of questions from each week so that at least we can focus on the
Yeah,
entire.
yeah. See, first week was easy. But
Actually, whatever they have categorized is only into these 4, like, right, for these 2 weeks, like spanning spaces,
yeah, 3 and 4
linear independences, axioms, and one more thing. So these,
yeah.
4 are basically the main topics for week 3 and 4, I guess.
Yeah, 3 and 4 covered all the 4 weeks portions. Yeah, so 3 and 4 is more important, I think, because almost all concept is there in these 2 weeks.
Anybody has prepared what are the key topics means, not the detailed one, because sometimes this terminology itself is little bit not straightforward. No?
Yes, that is there.
If is there any designated group for like for these concepts and all activity questions, like when you WhatsApp
Actually,
group
what
or
I am
something?
doing is whatever he is providing after the live session now, that is very handy. I am following that and trying to solve.
Yeah,
What
that is.
We have one more lecture activities / what was that?
Yeah,
I think
sorry, are you there?
yesterday
I
only.
lost my connection somewhere in between.
Sir, we are just
Sir.
discussing like regular, nothing related to
Am I audible?
questions. I mean,
Sir, we wanted to ask you about the quiz one. What are the portions and which week is more important?
So most of people
Left because you left. That's why.
I cannot hear.
Actually, we just wanted to share with you. Last time, Mr. Vicky and Mr. Srikanth, they used to share some last minute
revision, some
revision
pattern
session.
question.
In those, they used to share few questions or tips. Out of that, at least some 60-70% used to come. And in the similar lines, I'm not telling that it used to be
Am I
exact
audible
one.
now?
Yeah.
Okay. Sorry, I cannot hear you. So
he said so much.
Sir, is there any revision class?
Sir, what are the key topics which we have to target, sir? Because week 1 to 4, yes, it is mentioned.
He is offline again. He is offline again.
Yeah, he left the meeting.
Yeah. Now
Maybe he will join back. I think we have to ask this.
Yeah, now sir is there.
Okay.
Sujit, actually, we were discussing any additional classes you will be conducting for the exam.
So there will be one extra live session before quiz.
Sir, what will be the timing, sir? Because
okay, let me tell you.
Can you keep it 7 o'clock at least, because we cannot reach home by 6 actually.
So it is at 8 p.m. 8 p.m.
Okay,
Thursday.
that is good. That is good. Okay.
And I was thinking of taking another live session for those who have attended the week 1 to mock.
Yes.
So any of you have attended week 1 to mock?
Yeah, we have.
Yes, sir, we did.
So basically those who could not perform well, so they may have some problem. That's why we were thinking that will be one demand live session, but that will be on Gmeet. So
that will be on. Sorry, that will be on
Gmeet.
Gmeet. Okay.
Yeah, so
So
once
where
you plan it, we will give you the information.
Okay.
Sir, in the revision.
Now, if you perform well, you don't have to join that. But those who are struggling with that, we can talk a little bit about that also.
Sir, how will you provide that Gmeet link? I mean,
We will send a
may
mail
that-
to everyone.
okay, sir. Okay.
One more thing, sir. In the live
Huh?
session, revision session, will you explain like pattern of the questions or something like that? Some tips like how,
Do you need
what kind
pattern
of
of the
questions
question?
we will be, what kind of questions we will be getting?
So if you see the pattern of mock, that will be enough. Okay. So today there is a mock, right? Today to
Yes,
tomorrow.
yes. 8 o'clock.
So I will suggest you to time yourself for the mock also. I mean, it is open for 24 hours, but you time yourself. Once you see it, you solve the whole question and see how much time you are taking.
Okay.
Okay.
Okay, sir.
That I will suggest. So once you try using time, then you can try on your own because that is anywhere open.
Sir, this will be more conceptual, or we have to solve and get the answer, or something like
No,
that?
so always math to question will be conceptual. Okay, we will.
Okay.
I mean, it will not be calculative.
Okay, it will not be calculative.
It will not be calculative. It will always be conceptual. And you don't have to remember anything. That also I can assure you.
Okay, okay.
Oh.
So it will be more like this bonus practice activity, something similar, sir.
Which one? Bonus practice activity.
Some bonus. We have some bonus practice activity.
EMQ.
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 It will not be EMQ, but yeah, more of a conceptual questions.
Okay.
Okay. Sir, one more thing.
EMQ. Yeah.
One more thing. Last time for Max one, Mr. Vicky and Srikanth, they used to share some last minute revisions, which and also some questions, which will be more or less it used to appear in the exam. So
But that is not a good practice according to me.
Yeah.
Because if you know what kind of problem is going to come, then when you are working in a real life situation, what you will do? You don't know what type of problem you are. I mean,
even though
what problem will challenge you, right?
Sir, we couldn't hear.
Yeah, it's not a good practice, but
Yeah, you can hear me, no?
Yes, sir. Yes, sir.
We can hear.
We
can hear.
Okay, if not in the similar lines, any other way you can suggest or give tips?
Similar line means, I mean, try to, be clear at what you are learning, and don't read from here and there and confuse yourself.
Okay.
Many of you are doing that I know. That is for every batch, basically. You
Whatever
read
you are
from here
covering
and
in
there
the live
and
sessions,
Actually,
that
it's
itself
not
is
that
good.
he will actually share the.
He never used to share direct questions, sir, but it will be in the similar lines. He used to give some last minute.
Yeah, that I agree. That I know. Because
I
I
think
was also in
there is
preparation of
some.
maths one questions. Okay. So
Okay,
I know
keeping that apart,
what is going
sir,
on as
keeping
well.
that apart, if we go through all the live sessions and also the PDF, whatever you are
No,
going
he
to,
doesn't share the questions actually. He
okay,
give
that
actually attention to the important topics, whichever is
topic.
required.
Yeah, questions are never shared.
Yeah, that I know.
Never mind, we will not discuss that. Okay, at
So
least.
see, one thing I can tell you about maths too. Yeah, if you have discussed with your senior batch, maybe you know that in maths too, what we always try to do, we try to merge different concept in a single question. Okay.
Sorry, sir. Can you please repeat?
We give the attention to the main topics.
No, my point is once we merge different topics in a single question, then actually we can cover all the topics. So there is nothing called important topic. Every topic is important because all the topics are related. As we have seen, once I discussed week 3 and 4, there are many topics from week 1 and 2 also came in. Right?
Correct. It is all
And that
interlinked.
will go for every week.
No, it is interlinked. We agree, sir. That is one thing. If we miss 1 week also, we will be in trouble. That we agree. Okay.
So suppose if I tell you important topic is linear dependence or independence and finding basis. This is the important topic.
I
Right?
think so you
That cover
maybe the
all the
points are
topics
not
from week
put
1 to
correctly.
4. Yeah. Yeah, go ahead. You are saying something, no?
Sir, what he gives is he gives a little bit of idea.
I think it's network pro.
So, I mean, what I am trying to say is, in maths to take it little bit differently. I mean, this is basically more abstract than maths 1. In maths 1, you have to remember some formulas and all those things, right? Because those are basically coordinate geometry, different type of functions, all these are coming. But here you are dealing with some abstract situations, abstract notions. So you have to delete it separately.
So we'll have to develop a different kind of aptitude maybe for learning
Yeah,
this
yeah,
abstract.
yeah.
Like you have to create more analytical aptitude for solving
Exactly.
these
Otherwise,
questions.
you will struggle in machine learning foundation course.
Yeah, if we don't develop that aptitude here, na, and get easily the questions like that.
No, no,
I
we are
mean,
not
there are
trying.
two type of approach
Leave that
we are
topic apart.
discussing.
Okay, keeping that topic apart, if we go through all the whatever the sessions, what you do it after that, you upload the PDF. That is very handy. We appreciate that. If we go through it, I think that should suffice the need.
That should be enough, more than enough.
Okay, sir. Thank you.
That is more than enough.
So can you just tell us where exactly the PDFs are uploaded?
It's
It will be there in the download.
It's live session summary, na, supplementary content, live session summary.
Okay.
Sir, I want to ask
Supplementary
something.
content, live session summary.
Yeah.
Is the graded assignment solutions uploaded for all of you?
Graded assignment submission, I mean, for week 3, it is over.
Solution. I find only week 1 solution, sir.
No, so today afternoon I have uploaded that. So can you check that? Maybe before the session I have uploaded that.
Okay, sir. Thank you, sir.
Okay. Yeah, before the session I have uploaded both week 2 and 3.
Okay,
I thought that week 2 is already uploaded, but I saw that is not there. Don't know why. So I uploaded both of them.
Okay, sir. Thank you, sir. I thought only I'm missing it.
Yeah, okay.
Sir, that additional session, what you are planning, you keep it at 8 o'clock, sir. Please.
That is revision session is 8 o'clock, and additional on-demand session for week 1 and 2 that will see. We'll try to keep it in night. So let's see.
Okay, better, sir. Better, kindly.
Yeah. So I may not take that session.
Okay, whoever may, but keep it after sound.
Yeah, Shubham or Sushmita will take maybe. Yeah. Okay. Great. So it was
sir.
nice.
Thank you,
these
sir.
4 days. Yeah.
Thank you, sir. Thank you very much.
Yeah.
Thank you.
Yeah. Attend the mock.
Thank you,
Everyone
sir.
attend the mock. Okay.
Okay.
Okay, sir.
Thanks.
Thank you so much, sir.
Thank you very much, sir.
Yeah. Bye.